thank India Energy Forum for giving me this opportunity to address the August gathering today. I can started giving fruits, Terry and Pinapuram. I think Greenco, they are also going to be here. Uh, so I think what I'll start with is, of course, every one of us are aware about the need for hydro pump storage. Uh, but in the context, overall context of the country, when we had projected and when we are going for energy transition, we'll be requiring somewhere around 74 gigawatt of storage capacity. And then when we did the recent study of 34, 35, we found that this figure is going to be much, much higher than what we had projected earlier. Since the pace of achievement of solar and wind has also increased, last year we could had around 29,000 to 30,000 megawatt coming into the grid. This year we are expecting around 40,000 megawatt to be in the grid. And we have seen that this year, because of the low demand, there had been curtailments as well. So which also means that we need some sources which can store these capacities, and we should not allow the green power to be wasted. So we have the intention of accelerating the entire process of development of hydro pump storage. As far as, sir, the potential is concerned, as I had mentioned in my previous thing, that we are touching 200 gigawatt of capacity, potential capacity, which has now increased to 214. As I had said that every day, every month, we are getting informations from the new self-identified developers, mostly private, and they are try to identify new sites, and this has really picked up quite well, sir. And because of this, and mostly these people, they are concentrating on the closed loop off-stream hydro pump storage. Since the numbers are going to be very, very large, so recently you must have seen a notification wherein we had tried to ease out the concurrence process from the CA as well. And the amount has been increased from 1,000 crores to 3,000 crores, which exempts some of the hydro projects and hydro pump storage projects as well. And among the hydro pump storage, as I had mentioned earlier, that there are three types. What we have segregated them. One is off-stream closed loop. The second is off-stream open loop, and then on-stream PSPs. There are three categories. So particularly those hydro pump storage which are off-stream in nature, and they are not linked to they are closed loop and off-stream. They had been exempted as point blank, and we thought that that exemption will be helpful to all the developers because that used to be the demand of them. But of late, some of the developers, they approached back to CA and said that don't exempt us completely, because when we go to the financing companies, they do ask for some kind of a vetting or some kind of a concurrence. So even if you exempt us, probably we'll have to get those things vetted by some other organizations, which will be another painful points. So you must have seen that there is a small reversal to that policy, and that clarification had been issued yesterday, wherein if the developer wants to get it vetted or get it appraised by CA, they can still approach CA to get it done. And those who would like to get into the exempted category and want to go ahead, absolutely, they are also welcome. So since the kitty is going to be very, very large, and right now in the pipeline itself, we are seeing around 64 gigawatt of capacity, which is in this particular stream, out of which off-stream pump storage itself is around 48,000 megawatt. So that is how the decision was taken, so that we fast track this particular thing. But then again, one of the issue which still remains is what we have seen even the projects which have been concurred by CA, and one of the record project was that a project started, the first chapter was submitted, and within 1 year, the entire investigation had been done, and the project have also been concurred by all the appraising agencies and CA together. So that was the record time in during which the preparation of DPR and the concurrence of DPR has happened. So that's the kind of gear up that has happened among the appraising agencies as well as the concurrence process. So that definitely will continue for those who would still like to get it done from CA. But if they want to go ahead without concurrence also, that is also permitted for this particular kitty of this. But the major issue still remains is the environment and forest clearance. We have identified around 10 to 12 items on that as well. We had approached for 2, 3 items earlier to Ministry of Environment and Forest, which we are pursuing as of now, and we'll try to see that particularly for off-stream closed loop pump storage, how we can further ease out. Of course, they had already considered it, and they had already made certain relaxation for this particular category. But we need some more relaxations from them and how the process can be expedited so that we save around 6 to 7 months or even a year in some of the cases. Even after the DPR is ready, the concurrence process is over, still they are not able to, project is not able to take off because of the environmental forest clearances. So all these recommendations and churning have been compiled and have been given to Ministry of Environment and Forests. And very soon we are going to have a high-level meeting to sort out these issues as well. So coming to other aspects, some of the people they have also said about the insurance, which is going to be another issue, and because of the recent phenomenon which had been happening in the particularly hydro sector, the landslides, the cloud burst, etc., etc., and the sudden damages that has come. So I was told that insurance companies they are trying to increase the premium. So we are thinking of some alternative, and this is being debated. Maybe some recommendations can come out from today's discussion among this August gathering as well. That what could that solution be? There are two solutions as of now on the table. One is, can we levy 1 or 2 paisa to for the each generation or each unit which is being used from hydro PSPs or hydro, which can go in a small kitty and which can have a insurance fund or contingency fund sort of thing, which can be used to immediately relieve the developers of some of the contingencies. Second could be in terms of some kind of arrangement with the banks itself, wherein we try to ask them to have a concessional insurance with this. So maybe if some more suggestions comes on the table, because we have started deliberating very recently as the problem was highlighted to us, probably we'll be able to take it forward. Third thing that we are trying to see in this particular kitty is can we give them the same leverage as has been given to solar and wind in terms of the concession, particularly in terms of GST and etc. etc. So those have also been recommended by Ministry of Power to Ministry of Finance. And if that happens, maybe when we have the GST Council meeting, which is scheduled, I think next week, probably maybe we can hear some good news from there as well. If that happens, then definitely the cost will come down slightly less. So these are some of the points, sir, which I thought I'll cover in my initial speech, which where we are at as of now. And as I mentioned, that even though the potential is going up, but at the same time, the kitty has also gone up. And thanks to Tehri and Pinapuram, I think the representatives are presently in the hall. They have started commissioning their projects and they will commission the balanced units as well. So with that, the installed capacity definitely has gone to 6.7 as of now. Roughly 12 gigawatt worth of project is under construction as at present, and 5 gigawatt is balance, which have been conquered and which are waiting for forest environment and forest clearance, which needs the moment it happens, probably they will also go under construction. So if I include that, that means 17 gigawatt definitely will be under construction and which can fructify in next 3.5 to 4 years. But more important is the projects which are under SNI stage, which is 66 gigawatt as of now, whose DPRs are under at various stages. And if that is also completed in time, then we can try to see that they also fructify. So I think these are some of the things, sir, and I'll halt here. And in case anything is, if any one of you want to ask something which I can reply as of now, I think I'll be more than happy to answer those questions, sir. Thank you.
Sir, the kind of impediments which the hydro sector is facing, in addition to the forest clearance and long gestation period, but the logistics, because of the movement of the large components that's being in the pumped storage, also those will be impediments or.
Sir, as I mentioned, the we are targeting the peninsular area first, and there where the still the strata is good. So those area it is expected that probably so much challenges may not be there. So that's the strategy, sir. And moreover, second is in case any enabling infrastructure is to be made, like roads, bridges, etc., they are being covered under the enabling infrastructure, which can be funded by the government of India.
Now, are there any implications like thermal machines? The frequency variations, does it affect the hydro machines also?
The frequency variations definitely, of course, there are challenges on that, and I think Terry will explain to you that they have a variable speed machines now, so they can take up any kind of variations there. Of course, this is the first of its kind in India, and probably I think second or third in the entire world as well. This is what I've been told. But of course, not much, sir. But definitely, we need this kind of a capacity into the system because let me take you back to the recent incident that had happened in Spain. What we found there is there was voltage rise from the solar and wind because they are consuming around 80% of power is coming from the renewable segments, and this high voltage created all the nuisance, and they didn't had much of inertia into the system, and that is how they themselves collapsed and took even Portugal and even France certain portion, and the entire grid was in jeopardize. So this leads us to think more towards having more and more rotating machines, and hydro pump storage or hydro can serve that purpose as we go along in terms of energy transition.
Okay.
Of course, there will be some challenges, sir, because what I have also been told is right now the suppliers of hydro equipments are also limited. I think BHEL is also here today. Uh, I was told that BHEL is also coming. So maybe they need to slightly gear up. Ah, yeah, Mr. Rao is there. Yeah, good. So I think you also need to gear up to supply more and more equipments because otherwise Andres and other, there are only 2, 3 more suppliers who are here. And since the numbers required is quite large, so probably there might be some supply constraint in this aspect, which we are trying to see.
Can I just start?
Yeah, please, Rao Saab.
So
Go
you
ahead.
would recall that we had met around 2.5 years back in Bhopal. So,
Sir.
and we are continuing in that this thing. And actually today we are ready with with all what is required essentially in terms of design, in terms of manufacturing, in terms of anything essentially. And we are actively pursuing also our owners and customers and we are bidding in tenders also, sir. So since the last time you saw in Bhopal, there has been a rapid progress. Thank you.
Thank you. And let me inform the House that we are going to build one of the largest hydro pump storage, whose capacity is going to be 3,660 megawatt at single location. And this is the DPR is almost at a final stage. And if that happens, then probably that will be the largest one.
Sir, the manufacturing sector, the problem which they have been facing, I'm also from ex-BHEL only, and I was involved in the investment planning for capacity generation, enhancement of the capacity of power sector. Like the nuclear, off and on, a lot of capacity was created by L&T, BHEL, Thermex, etc. But it has not been matched with the orders. So they have diverted that facility and manpower to other sources. Even in hydro, I have a feeling they have this dilemma that if they invest and if they add capacity, whether it will be matched with the assurance on the orders. The percentage of hydro has been coming down, though absolute terms it may be increasing. So that is what.
Sir, narrative has changed, sir, and the things have definitely changed, sir. At the time that you are talking about, at that time, definitely we were concentrating on coal, and that was the need of hour at that time. But now, after the energy transition, which is happening, and which will be the order of the policies going forward, probably we cannot think of going back on this kind of a policy. So we have in our kitty we have solar, wind, and then nothing else other than the nuclear and hydro. So hydro definitely has to be there. I mean, hydro pump storage is further required because we need more capacity during the non-solar hours. That 6 to 7 hours is going to be more crucial for me, and that is how we are targeting this kind of an activity. So you must have seen, sir, last 3 years we had a huge amount of traction on this, huge amount of policy changes, and that has started fructifying now. So from this year onwards, the commissioning schedules are also in the pipeline. If I may tell you, I think we have this year alone, it is going to be 2,680 megawatt. Next year is 2,900 megawatt. And after that, in 28, 29, 6,000, then 29, 30 onwards, you will find 13,000 and more than 20,000 coming in a single year. So these things have started in the pipeline. They are already ahead of schedule size of now. So I have no doubt about the supply, the demand that has been created. The only thing is BHEL or others, they will have to gear up to meet this demand. It should not so happen as it is happening as of now in the coal segment. In coal segment, you must
BHEL in addition to, sorry, please carry on.
Yeah, what I was telling is because you must have seen that when we accelerated the pace of development of coal-based thermal power stations, the suppliers is limited now. It is only BHEL and just one more, or it is almost restricted to BHEL only. So that kind of a situation should not come in PSP. Otherwise, what will happen is the amount of momentum that we have gained, probably that will get retarded.
But
So that
BHEL moved all the hydro business from Hardwar and Bhopal to Bhopal only. But the facilities in Hardwar, they are still deficient of continuous order. So it can always fall back on those facilities which were created and they are still existing. As the load on thermal reduces, those facilities will be available for hydro. Am I right?
Good news, sir. So what I'll do is I'll have a separate discussion with BHEL in my office and we'll try to take it through, sir. Thank you. Thank you for the information, sir.
Ghanshyam, there were issues of quality control in forging and casting of the rotors of the hydro machines. I remember that one of the big rotors for being manufactured for Chukha project in Bhutan, that was rejected and there were cracks, etc. In that. Finally, it was imported. So, are we monitoring the quality issues and the capacity of the BHEL for manufacturing such large sizes rotors, etc., so that we don't face any constraints in regard to this?
So since not much hydro plants had come during the last, I'll say 10 years or even 12 years, and I think he's right in saying so that BHL had to close down their shops. But I think a lot of things have changed in terms of forging because when I visited Hardwar plant of BHL and I could see a lot of other activities happening there. Maybe Mr. Rao can supplement your questions.
Yes, sir. Can I just add, sir? Can I add? Sir, Chukha was long back. Beyond that, actually, in pellet turbines, we have moved to forgings, which are forged discs with CNC machining, 5 axis. And in case of big Francis turbines, that also we have moved to cast fabricated variant, whereby the restriction of casting in terms of tonnage is removed. So we can make the runners in 3 parts, that is crown, skirt, and blades separately. Then the blades are actually profile machined, 3 axis or 5 axis CNC, and then fabricated. So that way the accuracy has also increased, and efficiency has also increased, and reliability has also increased. So as of now, we have done 6 into 170 megawatt day before yesterday only in Bhutan. That is Punasanchu 2. We are also doing 225 into 4 Nepal, and 200 megawatt Punasanchu already boxed up, but waiting for water. So we have moved long ahead. And Mangadechu, of course.
I would like to supplement that the problem which the casting and forging CFFE plant of Hardwar faced was not really in terms of the size of the castings or forgings. It was basically the amount of repair which had to be done. The quality was not as good as we desired. And I was heading that plant, and then we brought in technology from Sheffield Forge Masters in Sheffield, UK. After that, the substantial improvements have been there. Now, with the cast fabricated structure, we are able to cover the entire range, but the repair quantum also has come down. So, quality has improved. So, I think the nation can depend on BHEL in meeting the capacity requirement for hydro.
Yes, sir.
I think let it not be confined only to BHEL because there are larger issues, and if there are other questions anybody has to ask.
This is a different issue, Ghanshyamji, altogether. I was just drawing your attention to the recent calamity that is taking place along the Himalayas. Now, that's directly connected to our hydro projects and their location, because the kind of ecological disaster that is taking place there. Do you think you would like to relook at some of the things? Because I was going through a very sane argument this morning, and that was that we should, rather than concentrate on single large projects, do a cascade of projects so that we don't stress the substrata that much. And at the same time, the costing may undergo revision upwards because you have to treat the catchment area and also the mountainside as you are getting your access to those areas in a much more professional way to prevent the kind of land slips and falls and disasters that are going on right now and will continue for a few weeks more, unfortunately. So do you think that your hydro planning will need a little relook and costing particularly? It's a call for all of us.
I think before you joined, sir, we had been discussing this only. I think in the last pre-start of the event, and we said that Uh, Definitely, it's true that in the Himalayan region there are challenges. There are more challenges, and these hydro projects definitely will have to be relooked in terms of the further safety measures from the dam side and the embankment side. But what today is we are discussing on the hydro pump storage, and we are also concentrating on the off-stream type of project, which will not have that much amount of challenges as we go along, sir. So this.
That's true. I think you see in pump storage, that issue may be reduced to a substantial extent because we are going in for smaller reservoirs. Of course, it will add to the cost because if you got to build transmission systems coming from all these cluster projects, it will certainly improve the cost of the project
So
and
that
the
we have.
need for road connectivity also. And that cost will also go up because the requirement for the road connectivity and the disposal of some of our hydro excavated material will have to be taken up much more seriously. Because if you are going to create mountainside roads and you are not going to do slope treatment adequately, or you're not going to put meshing on the steep rockfall sides, we are in for trouble and the whole project's future may be in jeopardy. But I'm glad that you're already looking at all these things.
Sir,
I'm
definitely.
joining a little late.
I want to add one thing that most of the PSP projects are coming in the western and southern regions where the
Absolutely.
technology is not a problem.
Absolutely.
That is true. In the Deccan region, it will be certainly much more congenial with the rock
So as
condition
far as
there.
the PSP projects are concerned, there is no such problem.
Yeah. So I think Rakeshnath ji has already clarified, sir. So definitely that will be taken care. And as far as enabling infrastructure is concerned, which already covers road, bridges, etc., etc. So we'll try to take care of that and try to see that these costs doesn't load the hydro segment as of now, so that the cost remains within control. One more thing, I'll request all the developers. Some of the developers are also here. That please do use the independent engineer route or the as possible. And this we have seen that some of the PSUs who have used this route, they have been able to resolve the issues much quickly. It's another very good mechanism which has been a good initiative of Ministry of Power. And we are going to impanel some more independent engineer very soon. So please do try to take the help of the independent engineers and the disputes resolution committee instead of going to court and other places or arbitration, which takes much longer time horizon. Okay.
Yes, Mr. Chairman, Central City Authority, I think this is one of the most fantastic and revolutionary initiatives that has been taken in recent past, because we have been struggling to find the backup for solar. We are struggling with hydrogen, we are struggling with pump storage, one, and then we are struggling with battery storage. I think this initiative is the best of all because the longevity of these projects will be so much that none of the other alternatives that we are talking now can match the requirement of the massive expansion that are taking place in the country on solar side. I did bring out to you once when I was in the midst of such a discussion when people said that the old system of MOU with the chief ministers and the ministers have started happening. And then that was giving rise to some sort of licensing. And I did mention that power generation is delicensed. In the hydro sector, we made certain provision for concurrence by Central City Authority and CWC. On that, you have already taken action. I think the amount of seriousness and the importance that this subject deserves that has been taken at the central government level that must percolate down the line. Because I have definite information that when it comes to forest department of the states, investigations are stopped, taking permissions becomes a problem. Then you have the wildlife and sensitive zone issues. I think one point that you made, that Environment Ministry and Power Ministry, they are engaged on trying to see how best some sort of dispensation is agreed, because this is definitely a less harmful, much less harmful as compared to other hydro projects. And particularly the closed loop on which you have given the relaxation is absolutely, we should not fear at all. And developers should engage expert agencies so that things are done better. I think the steps taken themselves are very good, and I must congratulate Central Electricity Authority and the Power Ministry and other departments. And some of the steps that you said, that incentivizing this initiative, because the type of understanding and the type of positive feeling, and rightly deserved positive feeling, that we have at professional level, at Central City Authority and Ministry of Power level about PSP, that has to percolate down the line in the states and as well as in the ministries. To that extent, concessions like GST and other incentive should be available to this, because this is the only thing I can see in the scenario that is going to be the savior of expansion of solar power. And the 200 gigawatt, that means 200,000 gigawatt, that is 2 lakh gigawatt of capacity, and the amount of benefit that it will bring. One of the other points that also needs consideration of Central City Authority, that in the recent past, decentralized solar, DRE, decentralized renewable energy, all the states have gone for 5 megawatt, 3 megawatt, 4 megawatt. I think many PSPs for them that could save us a lot on transmission system. So therefore, one item on the PSP could be, wherever possible, that besides the solar system doing the rural area, and in evenings backups are needed. Maybe some of the studies that could be done perhaps by the Central City Authority, and some guideline could be done on that. I think the rest of the things you have also said, but my own assessment is the confidence that we have about the system at your level and at the central government level. I think you could organize the power ministers or chief ministers conference with the environment ministries of or environment departments of the states, so that the importance of this, as we understand now, is understood by them. That this is the only and perhaps the most important source of support for the transition that we are trying to manage. So I think that couple of suggestions I think we could keep in mind, and it should in no way be allowed to go through MOU route, so that it becomes an indirect licensing system. Thank you very much.
Thank you, sir. I have noted the points. Definitely, environment is definitely a major concern, sir. And we have now listed out all the points which we need to take up with the environment. We have all started taking up, sir. And let me assure you, sir, with the highest intervention, probably we'll be able to have some more relaxation. What we have recommended there is even for the closed loop hydro pump storage, which is the largest kitty that is going to happen, can we exempt them from the environment and forest clearances? So this is the ultimate that we had asked. Let us see how much they concede to. But I think definitely we'll be on the job, sir. Thank you, sir. Thank you for giving me this opportunity, sir.
Thank you very much, Mr. Prasad, for joining us today and sharing with us the policies of the government and clarifying many of the issues. As Mr. Prasad had to go for another assignment, now I think we'll go ahead with the program as notified earlier. Thank you very much, Mr. Prasad.
Let's give him a big ovation before.
Thank you, sir. Thank you so much. Thank you.
With the permission of President IEF, I think we should start with the formalities. I mean, bouquets to the person, THEL, THDC, and the Greenco, who have joined us for sharing their experiences. So I would request Shahi Sahab to give the bouquet. Please start the thing.
You are the vertical
No, no, it's okay, sir.
Thank you.
I am only president, you are the chairman.
He will also give that. but
चलिए,
Start with you.
कोई issue नहीं.
Here is Mr. Neeraj Verma, the CM THDC could not come, but he
What
is
happened to Mr.
executive.
No, but we welcome you.
Mr. Neeraj Verma, the executive director of TIGC, yesterday night, TIGC told me he is not able to come. So
But we'll convey this whole program on design
yes, sir.
around Vishnu.
I have told
The
him.
number of
sir,
times
Yes,
Mr.
yes.
Prasad mentioned Mr. Vishnu has said program must happen.
No, no.
But Mr. Verma is
I think he personally conveyed
I will,
that due to the flood situation and the rescue operations in the state, he expressed his inability.
yeah. Mr. Parveen from Greenco. Mr.
Mr.
V.S. Rao is the general manager BHEL. Sorry.
BHL will have a huge task, a huge opportunity. What you lost in thermal, you can make up here.
Thank you very much, sir. Sir, since, with your permission, sir, I would now request Shri Dr. H.L. Bajaj to deliver the welcome address.
I think
Although it is, certain things have already taken, but as a formality, we would request you, sir.
let's not go with the formalities. All I would say is that our next program in November, December will be specifically for dealing with the problem of, the role of conventional energy in the non-conventional dominated power grid. So that's a big challenge, and this will be, of course, continuation of the storage. Whatever. Okay, we'll notify. But again, we'll talk of progress made in the pump storage projects, storage batteries, and why it is necessary to still have more of the conventional thermal power stations and the flexible operation of the thermal power plants, two-shift operation, etc., and preparedness of the manufacturers to provide equipment, the generators with high ramping up and down rates. So that we'll have in 23rd now is done? Okay, 23rd December. All right. With this, I think we should go with the.
I think, sir, as a formality, after your welcome address, we would request the president, Shri R.V. Shahi Sahab also, to give his presidential address.
Mr. Bajaj, Mr. Razdan is just joined, and other friends, all the speakers, panelists. This discussion with Mr. Ghanshyam Prasad, first his own address, followed by extensive discussions on various issues, itself has put the whole subject in the right perspective. And some of the points that I made in suggesting a few interventions by the government that could further enhance it. The concerns expressed about the size of expansion that we are talking, which is rightly deserved, and particularly with reference to the manufacturing sector, is the right concern, because the type of potential that has been established, and that is now 214,000 megawatt of pump storage in the country. That's not a small number. And already some of the projects that have started, I think BHL share is comparatively
less. So therefore, BHEL and other manufacturers in the country, I mean, it's not a question of only BHEL, it could be a private manufacturer in the country. Manufacturing sector must come to the requirement, because what happened in case of thermal, that when we opened up the sector, we tried to have a number of manufacturers in the system. But unfortunately, that was followed by coal problem, the Supreme Court cancelling coal block allotments, and then the large number of projects getting into trouble. And then following that were the COP series of discussions on climate, and therefore thermal was put on the back burner in a way, which has again revived. And that gave rise to closing down of many of the manufacturing facilities that got created uh, following the opening of thermal sector and other sector in the country. I don't think some point that were made, I think Mr. Mahajan made that point. I don't think that should repeat in respect of so far as pump storage is concerned. Because I have been very keenly assessing, trying to interact with people, trying to learn from these discussions as also from literature available and the developments that are taking world over on the field of energy transition, energy management. Definitely solar, there is no going back. There are problems have already started surfacing. There could be issue whether the pace could be slightly moderated or will be kept as such in the light of transmission backup that may be required, that may be done also, but may not be only coinciding with the expansion that are taking place on the solar side. Like some of the massive solar expansion is being backed by HVDC system. Solar comes in 6 months, 1 year, HVDC will take 3 to 4 years. So that type of mismatch might happen. So therefore, the final figure or the figures in the next 5 years, 10 years could be as we project, but the pace of development may require some moderation in the light of these transmission things. Another issue that has emerged is also the decentralized solar system, where then transmission will have a positive effect. And to that extent, we will have to revisit in what way national grid or the state grid system needs strengthening, corresponding to the local strengthening that can be adequate in many such cases in the rural area. But backing up solar in evenings, I think out of, as I mentioned just now before Ghanshyam left, that in my assessment, all these opportunities are valid opportunities, whether it is battery energy storage or hydrogen in some way. Hydrogen is a little behind. But pump storage, because of the life of these projects, and once loan, etc., is paid, like it happens in typical hydro projects, the financials of this will be most important and most satisfying. So therefore, this is an approach. It's not new approach, but it has become relevant now. Pump storage was always relevant, but to pump thermal power with carbon dioxide associated and get 80% of that power back or 75% of that power back was neither economically sound at that time, nor from the climate concerns that was sound. Now, answer is here that to pump up this water, you are using solar power, which is less expensive, and then you are getting 80% of that power back in the evenings. So this technology, technically, and in the long run, from financial point of view, would be more lasting and more satisfying and more sensible. And this is not to say that this is the only option that needs to be deployed, because the requirement of backing up solar of the order of 700,000 megawatt or 1,000 megawatt would not be only with pump storage. But in time to come, maybe 5 years, 10 years, 15 years down the line, this could emerge as the most important contributor to that requirement. And the point that I made, that even in the decentralized system of supply in semi-urban and rural areas, smaller PSPs would be considered, that it cannot be as extensively potential-wise everywhere possible, but then wherever it is possible, that needs to be done. I made certain point about the importance of this to be disseminated among the states, because interactions with people who work in different places, different states, reveal that the type of understanding and appreciation of the role of pumped storage in the revised or changed context of energy transition management is there at higher level, at maybe government at the center level, is not existing at levels where implementations matter, where implementations are sort of delayed or implementations are not supported. So that missing link will be very important. From our side also, we'll be following it up with the Ministry of Power, Central Electricity Authority. Informally in this seminar, we have already conveyed it to the Central Electricity Authority. But I must say that the government response on these matters has been very quick, very positive, and that is a good point. Biggest concern, like in solar it happened, our programs on solar, even today, is heavily dependent on import. So I think import dependence on manufacturing is an issue which could be here. This is not so technically, process-wise complicated as solar. So therefore, it is mechanical engineering, mechanical processes, and therefore the existing manufacturers, they may not be pump manufacturers, they may not be turbine generator manufacturers, maybe a discussions and a workshop, all such engineering, large engineering factories and companies could be organized so that whatever is the requirement, the types of requirement as Chairman Central City Authority said, and some of the things have already started happening will be so huge. But in my mind, perhaps one is states cooperation in terms of clearances on environment and forest, including the Ministry of Environment at the government level. And second, the manufacturing inadequacies. These could prove a little troublesome, and that is what we will also try to follow up from India Energy side and from our own discussions as well. With that, I thank you very much, and let's have the other program.
Thank you very much, sir. The various elaborations, sir, which has been done by you on the pump storage projects, it is really, you have done in a very concise manner and given the total input which is required both from the government side and from the developer side. In fact, sir, you have rightly said that the thermal power using by the pump storage, I mean, it was not very economical. And now with this solar and wind projects which have come up, it has given a flip to the development of the projects and the government policies which have come up recently, particularly in 2023. The pump storage projects have given lot of importance in the development of the on the hydropower sector side. I would just mention, sir, I mean, during the regime when you were the secretary and Mr. Anil Rajdan was also the secretary power after you, during your regime, when the Tehri complex was conceived as 2400 megawatt complex, the 1000 megawatt complex, it's a Tehri Dam project that was to be commissioned initially as stage one. But if we have to commission the Tehri pump storage plant, there are certain works which were required to be completed as part of the Tehri stage one, particularly the intake side, because once the reservoir side is filled up, it was very difficult. So a decision was taken at that point by the cabinet, and the certain works were completed along with the Tehri stage one. Now coming to the Tehri pump storage scheme, way back almost about 18 years back, when we were trying to get the government sanction, it was really a Herculean task. It took almost about 3 years. Mr. Shahi personally took lot of interest in getting the this our power purchase agreements agreed by the various states. In fact, he called the Delhi Chief Secretary and told, you take 600 megawatt, it will be very beneficial. The only thing was that Punjab was not agreeing, and Mr. Rakesh Nath ji, he has pushed the Punjab during the NRPC meeting, and he also agreed. And ultimately, almost after 3 years convincing the CA, government, states, and this, you are able to get that permission. Now, during Mr. Razdan times, the point was that whether we should have a synchronous machine or an asynchronous machine or a variable speed machine. It was a very tough task because everybody was asking, where is the experience in the country? So, in fact, I told Mr. Razdan that we should be the leader, not the follower. So, he has sent me along with the team of THDC to Europe and see the power stations and see how it is possible. So, I will just give one example, sir. I mean, I will not take much time. We visited the Golders Hill power station in Germany. There were 4 machines. 2 machines were synchronous, 2 machines were asynchronous. We were told that only asynchronous machines are running because their grid is such that when, first from the frequency point of view, any fluctuations, when they need the machine, so immediately the variable speed machine can come faster than a synchronous machine. So that is how this technology for the first time in India was brought by THDC, and details we will see during the presentation given by Mr. Neeraj. So from that angle, it was a very tough design also because there is a 90-meter head variation for the pump turbine runner, because firstly it was for the synchronous machine also as stage 1, that was its task. But here it was more task because it is another 30 meters below the riverbed level. So anyhow, that was the THDC has done an excellent job. That is how I requested Mr. Shahi that we should have a special session. Unfortunately, Mr. Vishnoi could not come. Yesterday night he telephoned me, although his flight was booked, but he had to cancel because of the floods and Chief Minister, calling for a meeting and all those things. Then he asked me that Mr. Neeraj Verma, he is the executive director, so he has deputed him. So I would request Mr. Neeraj Verma, you see, he has been responsible for the development of pump storage projects and also the RE projects. No, he is basically a electronics and communication graduate of 1989, more than almost 30 years, 33 years experience in the field of hydro projects and RE projects. So he has an extensive background of control, protection, and switchgear, etc. And he has done, particularly for the Tehri stage 1, also a lot of work he has done. And he was associated vastly with the Tehri pump storage design and engineering aspects also. So I would request him that he should take over and the THDC presentation in detail. Kindly, Mr. Neeraj Verma, you are welcome.
Thank you very much, sir. And first of all respected dignitaries on the dais, Shahi sir, then Bajaj sir, Razdan sir, and then Mahajan sir, V.S. Verma sir, S.C. Sharma sir, and our Arora sir. He is also Director Technical, former Director Technical, all the eminent personalities, Nath sir, and from my peer group persons from BHL and Greenco. Sir, definitely, sometimes we feel that how it could conceive in those days, early 70s, the State Irrigation Department conceived that this concept of PSP. Those days, nobody was able to see the way forward, how to go ahead with this implementation of such a large PSP at mega project at Tehri, and the proper utilization of this scheme particularly, because those days, it as a hypothesis in initial DPR, it was envisaged only for 4 hours pumping during the night time. when it was considered that thermal generation is going waste. So that was the only concept initially. But nobody thought probably within even TSGC that the day would come that PSP will be proved as a milestone and of such an importance to India's grid stability and all the aspects. Whatever Sir has informed that variable speed machine was conceived, that is no doubt depending on the situation, because it is having 188 meter rated head, then 90-meter variation in upper reservoir. So VSI, this technology has proved slightly complicated, undoubtedly slightly costlier also, but has proved very much beneficial for Tehri, especially in this particular initial start when the RE is also not stable. That is variable depending on the season and all. So it can work within the range of plus to minus 30% of power input. So we do have 4 states or now 5 states beneficiaries with different segment of 1,000 megawatt. All power is intact. And now we are going ahead with more PSPs in the state of Maharashtra, then Gujarat, then Chhattisgarh also, one in UP also, to go ahead with off-stream PSPs, closed loop, open loop, both type. And what CA chairperson has just informed that so many facilities have been extended for faster development. However, for a PSU, faster development in comparison to private sector is slightly more difficult because we have some limitations in going ahead with the construction methodology and start of construction without having clearance from the public investment board and all. So this particularly today, because we were given a task. And first, moreover, sir, I would like to just extend sorry on this part that our CMD sir could not come because of multiple cloud bursts in hills, especially in Himalayan region. And one project at Pipalkoti, very close to that area, we had some slippage at Pipalkoti main dam area where construction is being carried on. And now near to that area again, cloud burst happened 2-3 years back. So that is why CMD sir could not come. Otherwise, he was highly willing to have this session along with these dignitaries at this place. And he has deputed me and my team also, sir, to just deliberate on the basically implementation challenges, what we faced and how we mitigated them. The challenges, especially civil aspects and EM machine commissioning aspects also. So this integrated philosophy also we have got developed because it is a scheme having this 1,000 megawatt Tehri, then 400 megawatt Kodishwar. In between this is scheme PSP. So without impacting the generation, already designed energy of Tehri and Kodishwar, we have devised a methodology in association with IIT Roorkee. It is totally software based, so that to optimize the generation at different time segments given by this NRLDC. So that it is working properly because it was even placed before CA also. Presentation were made at 3-4 times. They also suggested some improvements. Then finally it will get more improved based on the experience because 2 machines already commissioned and rest 2 are in underway of commissioning. Maybe by October and November, another 2 machines will be commissioned. And this time, especially in flooding season, all 6 machines, 4 from Tehri and 2 from PSP are working in that generation mode also to just pass on the high intake from upper hills from this catchment area. So if kindly allow, sir, my colleagues, Mr. Mittal, then Anil Agwanshi and Ashish, they are here, sir, to speak about in detail on these challenges. Thank you, sir.
Thank you so much, sir. Respected all the dignitaries present over here. Thank you for giving opportunity for presenting our perspective on the Tehri complex. Sir, actually, Tehri PSP is the 1,000 megawatt pump storage project consisting 250 megawatt 4 number of machines. It is a part of the Tehri power complex, which is having the 1,000 megawatt Tehri HPP, which is commissioned was commissioned in the 2006-7, and the Koteshwar 400 megawatt project commissioned in 2011 and 12, and the Tehri pump storage plant, which is under construction, 2 unit has been commissioned. The Tehri dam, the Tehri reservoir is created by the Tehri dam and having the live storage capacity of the 2521 MCM. And the downstream project is the Koteshwar HEP, is located 22 kilometer downstream the Tehri dam. And the live storage capacity of the Koteshwar is the 35 MCM. The reservoir created between the Koteshwar and Tehri serve as a daily regulation reservoir, and also serve as a balancing reservoir for the Tehri PSP. Total 15.6 MCM water storage capacity available between this reservoir for pumping operation, in which the during pumping the water from the lower reservoir, Koteshwar reservoir, pump back to the upper reservoir, Tehri reservoir, and during generation, upper reservoir water releases to the lower reservoir. And this is the infrastructure of the Tehri power complex. The Tehri HPP and Tehri PSP both are co-located and share common infrastructure such as the dam, lower reservoir, upper reservoir, and the transmission system for power evacuation. The 400 kV GIS are common for both the project, Tehri PSP and Tehri HPP, and connected to 3 numbers of 400 kV transmission line to the Koteshwar pooling station, which is developed by the Power Grid Corporation of India. And then further, this 400 kV voltage level stepped up to the 765 kV and connected to the Meerut substation. And the Koteshwar HEP also having double circuit 400 kV in transmission line, which also connected to the Koteshwar polling station. The total for the operation of the PSP, we have the 6 meter of the live storage capacity between 606 to 612 meter for pumping the water from lower reservoir to upper reservoir. 6 meter, and the gross storage of the Koteshwar is 35 MCM. Out of that, only 16.7 MCM we are using for the PSP. These are the silent features of the Tehri PSP. Tehri PSP is a kind of the on-stream PSP because both the reservoir are located on the river range, Bhagirathi River, and this project is equipped with the India's first variable speed doubly fed asynchronous machines. It has the large net head variation from the 127 meter to 227 meter. The doubly fed, the characteristics of the doubly fed induction motor is that power can be exchanged through the both rotor and stator. The variable speed operation. In variable speed operation, the speed range is from the 206 to 250 RPM, and the 230.77 is the nominal synchronous speed. And it is fitted with the VSI system, rotor is fitted with the VSI system that enable the pump mode starting and the optimal operation of the machine for a given set of conditions. And the powerhouse is underground powerhouse, capacity 1000 megawatt, rated voltage, generator voltage is 15.75 kV, rated at 188 meter, rated output to 50 megawatt, overload capacity to 75 megawatt in generator mode at the speed at minus 7.5%. It can generate up to 40 MVA, and at the speed at plus 7.5%, it will generate 306 ampere. Similarly, in motor mode, at the speed of minus 7.5%, the synchronous speed at take the power soft power of 224 megawatt, and for higher speed 7.5%. It take the power of 286 megawatt, and the speed extended speed variation can also be possible here from minus 10.7% to 8.33%. The transmission voltage is 400 kV. And the first during design stage, there was a constraint to select the machines because we have the very large head variation. Due to the large head variation, which leads to the high variation in the power absorbed by the pump, large area of performance, high risk of cavitation. During the DPR stage, the study was carried out for the submergence. Submergence in that study, if due to the large discharge of the machines, for the fixed speed machines, it will require a submergence of minus 150 meter. Means in case of fixed speed machines, we have to excavate the powerhouse up to the 250 meter for the setting of the turbine. And by using the variable speed machines, the submergence is only 40 meter. And also the head ratio is 1.78 meter. As per the report published by the CEA, the variable speed machines will be used after for the head ratio more than the 1.35 35. And also because of the using of variable speed machines, we have improved efficiency of the cycle efficiency of 80.01%, and the saving in the both the power energy during the pumping as well as the generation. This is the schematic diagram of the TEHRI PSP. Shows the asynchronous machines connected to the turbine, reversible turbine with the shaft and the rotor circuit breaker and generator circuit breaker, direction reversal switch used for changing the direction in the forward direction and reverse direction based on the selection in pump or generating mode, main transformer and unit circuit breaker at 400 kV inside. The main transformer is fed the supply from the main transformer also fed to the voltage source inverter, which is a converter which first convert the AC into DC, then DC into AC, which is fed to the rotor three-phase bindings provided with crowbar for the over voltage protections. Both the voltage and frequency of the rotor can be adjusted by this voltage source inverter. And this is the basic principle of the variable speed, because this variable speed machine, asynchronous machine, never operate at the synchronous speed. It will operate on either on at the subsynchronous speed or supersynchronous speed, means higher than the synchronous speed or lower the subsynchronous speed. When this machine is operated at the subsynchronous speed, then the total mechanical output power equal to the soft power. The rotor will draw the power from the grid. If it will operate at the over synchronous speed, super synchronous speed, then the mechanical power will be divided in two parts. First part is gear power, stator power, and the second one is the rotor power. Both the rotor and stator will feed the power to the grid. Similarly, in motor mode, in subsynchronous, the mechanical power, the stator power will be the grid power, and for the supersynchronous mode, the power further divided into the stator power and rotor power. And because since all three projects are the complex which having the three projects, and both the TEHRI PSP and HEP, TEHRI HPP are co-located. So and the project is multi-purpose project. It serves the requirement of the irrigations, drinking water, and the religious requirement. So to provide the optimal operation and to have the solution for the optimal generation from all these projects, we have developed the real-time simulation model for integrated operation of the TEHRI power complex. We propose some determinants such as compliance of reservoir rule curve, and the optimization of generation and plant ability of TEHRI HP without changing the design energy, outage planning of plants for maintenance, technical constraints such as a cavitation, design criteria, past performance, and operating limits. And also the compliance of e-flow norms, fulfillment of the irrigation requirements during the splash condition. The PSP will operate in the conventional mode of operation without will generate the power without an pumping operation. For the operation of TEHRI HPP, it is a multi-purpose project. Provide the drinking water for Delhi to 300 cusecs, for UP 200 cusecs. Irrigation command area is 8.75 lakh hectare. It's also provide flood control, peaking power, ancillary support, like automatic generation, secondary reserve, and primary reserve, and release also released during the religious Kumbh Mela, Mahakumbh. Plant operated in align with the operation of the reservoir management rule curve. Annual reservoir head variation 90 meter. The capacity of the HPV varies between from 121 to 250 megawatt. The Koteshwar is the balancing reservoir and release the water in the regulated manner as per the irrigation requirements. Moderate the water fluctuation caused by the peaking release of the Tehri HPP. One unit of the Koteshwar HPP operate around the clock to meet the E-flow requirement. During peaking, all 4 machines are operated at their capacity. And the Tehri PSP is the energy storage system. The cycle operation as per the seasonal requirement and the reservoir head available. The cycle efficiency is higher than the 75%. It's around the 80%. And this is the operation philosophy of the plant in which the operation of the Tehri PSP formulate honoring the operational commitments of the HPP and KHGP. Release from the Tehri HPP shall we continue in line with the EPID demand and reservoir rule curve. Daily discharge of the Tehri HPP shall be equal to the daily discharge of the KHP. Whatever discharge released from the Tehri HPP shall be released from the Koteshwar HPP. And E-flow and water release requirement for E-flow and water requirement 1 unit of Koteshwar HPP operate 24 hours. The cycle operation, Tehri PSP utilize the water in turbine mode, which is pumped from the lower reservoir to upper reservoir between the Tehri and Koteshwar at the level at 610.5 to 612. The boundary condition is that the live storage of 606 to 600 meter of the lower reservoir shall be utilized for cycle operation. Annual variation of upstream reservoir from the elevation of 740 to 830 meter, and the Tehri PSP utilized at the EL 829.6 for pump mode operation. And constant are because there are common structures. The simultaneously operation of the Tehri HPP in generation and the PSP in pumping is avoided, because when both suppose in case of Tehri HPP is operating generating mode and PSP is operating pumping mode, there is a kind of the closed loop will created between these plant, and both are connected through the common bus system and common evacuation system. Then net output will also be insignificant. It may be positive or very significantly negative depending on the their operating range.
Just question the monsoon season when Tehri Hydro
Yes, sir.
operating round the clock in emission mode.
Yes, sir.
And you can't operate it.
Pump mode. Yes, sir. Yes, sir. That it is our philosophy, sir, because since there is if we operate the Tehri PSP in pump mode in that time, because both plant are co-located, upper reservoir and lower reservoir both are common, and our transmission system also common. So in that case, that net output, the water release as well as the power output will be approximately zero, sir.
So in the monsoon season, ESP will not operate.
Will not operate. It will operate in the conventional mode when the hydrological inflow are more. Right now, it is operating only in the generation mode. We are not pumping the water from lower to upper reservoir due to high inflow. Not pumping. At present.
Yes, sir. Sir, I would just like to add on this. Basically, initial philosophy was only this, that it will work only during non-monsoon season. But later on, when this integrated study was done, then we found through that study was evolved that the machine efficiency is not impacted between 829 to 830. So there is a cushion of 0.4 meter. Now, the reason for a round-the-clock operation happens only because of high input from the catchment area. So we have to release that water through machines only, not through spillways initially, but basically. So now in the present scenario, for example, this one machine output is nearly 146 cusecs, maybe 150 cusecs we can say. So it was able, 4 machines were able to release 600 cusecs. So out of that, if we release just double that, 1200 cusecs, so it would not be required to operate round the clock to release the water to safeguard the high flood season. So in that case, we will be able to pump back during the hours available other than that period. That is the modality. Definitely would be able. We will be able to manage this.
The point is made that you are not pumping now.
At moment, because of this particularly for last 2 weeks, high inflow. Otherwise. हाँ sir. Yes sir. Yes sir.
No, but the 2 units which have been commissioned.
Yes sir.
What is the periodicity during which it operated as pump and generation both?
Sir, presently only 6 hours in this during the hours.
The entire year, let us say.
Yes sir.
What period is
Sir, this is our after multiple cycle of operation. Based on the discussion with the beneficiaries, how they will arrange it, because there are 5 beneficiaries of this project who signed in the PPA: Delhi, Rajasthan, Haryana, Uttarakhand, and Gujarat. So, sir, based on discussion with that, because as per the PPA, they have to arrange the pumping power, sir. And we have to generate according to that. So,
what is the statistic? Say if you take this 1 year commission, 2 years commission, these 2 machines have been commissioned for 1 year.
No sir, just June and July. 3rd June and 7th July. 2-3 months back.
So we have no experience of pumping.
Yes sir. Yes sir.
So my just a little query, because you see, I think from what you're describing, the precipitation and the reservoir capacity seems to be, exceeding now, because you had not visualized that there'll be so much precipitation
Yes.
in the area probably. नहीं, जो आप कह रहे हैं ना कि you are unable to operate this because your reservoir is full. So that means that for about maybe 2-3 months in a year, you will have to suspend your operations.
No sir, no. Basically, what we have 90% dependability design curve, what the base on which our machine operates, that is based on the past history of hydrology. What happened, no doubt, sir, it happened in 2010, then 13 also, and now. So it is happening more frequently with respect to past 80-90 years.
No, that's what you see when you have when the planning was done. So over the last, say, decade or 2 decades,
yes sir,
with global warming or whatever it is, moment you see, in fact, you'll have faster melt of glaciers. So you are going to have more water inflow into the reservoirs. That is what I visualize. Try and see the larger picture. What I see is that this reservoir is going to have more water than was planned. No, just a minute, please.
Yes.
If this is the case, then we've got to start working out more generation from this project instead of what was originally planned. Because you have the fall there, you have the gradient, and now maybe you have to work out a secondary scheme, seeing the water flow pattern. If it is increasing, it's excellent for the water supply utilization downstream for drinking water, canals, etc., etc. They will be in any case utilizing this water. But you as a generator, rather THDC, has probably the opportunity of trying to see if you can get more generation out of this larger precipitation. Don't you see, try and jump to a conclusion, see a larger time span period of what is going to happen.
Right, sir. Basically, what just I mentioned in the initial remarks, that initially it was planned for 270 days in a year, but now we are increasing it to close to 365. However, still there is a possibility that we may not be able to even pump during maybe 20 to 30 days in a year, but not more than that.
How do you
for
get
sure.
How do you get the head?
Sir, head is variable, no? So that because our reservoir get the curve of the reservoir, it is between June to July to June. So now it will get full, it will reach to maximum level, maybe 830 or 829.5. Then throughout the year, then it will start depleting. TSP will be based on the water pumped, not on the level of head. It will based on the water pumped to upper reservoir. However, the machine efficiency or machine output would definitely depend on the available head on the upper reservoir.
Point that in a year, not more than 20, 25 days, 30 days, it will require to pump.
Yes, sir. Vice sir. It can't pump.
It can't pump.
Yes, sir.
But you see, what I'm trying to say is that the volume of water which you had estimated that.
Yes, sir.
After these estimates were also made about 30, 40 years ago.
Yes, sir.
Now,
Height.
with the condition, now with your precipitation that you're going to have, which is you are yourself saying that it is more. I think it's more for the Terry project people to start visualizing that now can we get more generation out of this water because the gradient is there. Yes. And can you increase, I mean, somehow the reservoir capacity of these reservoirs for your pump storage, etc., is any enhancement possible or no?
No, sir. Enhancement is not possible because it's a earthen filled rock dam, and the capacity of the whole reservoir is 2615 million cubic. So MCM, cubic. So that is good enough. However, the glacier, due to this temperature change and all, that is not impacting the inflow. But sometimes, like I just mentioned, 3 instances in past 15, 17 years since our tariff storage happened in 2006. After that, only 3 instances, 10 and 13 were major. Rather, it proved to be a safeguard to the flooding down the stream. And this time also, it is not to that extent what was observed in 10 and 13.
See, just still, I feel that there is some scope for your rethink. I'm not saying that you raise the level of the Terry Dam.
Yes,
You
sir.
can't do that.
Yes, sir.
That is a fixed.
Yes, sir.
But a reservoir capacity goes not only by the height of your dam, it goes by the spread of the lake. So maybe or some feeder somewhere else you can trap those waters in smaller capacities because precipitation and if glacial melt, what is going to happen? With faster glacial melt, your water inflow into your systems is going to increase. There will be a time when it will be drained out because those glaciers which are
speak something on this. Yes.
I was also working in I was also working in TSDC. So as Brahma Sahab has explained, hydrology is probable hydrology, and we study for 90% availability of water in the reservoir, and not a single year is similar to other year. So every time we receive different volume of water, quantum of water. And for managing the reservoir, we have a full-fledged reservoir operation department who gets the data of rainfall, which gets the data of meteorological predictions, which get the data of snow melt, because we have various stations around the catchment area. And our first aim to fill the reservoir as quickly as possible, but not lose the amount of water so that we are compelled to release through spillway. That's why some year we have very high energy and some year we have very low energy. और आपको याद होगा सर, जब आप MOU की मीटिंग करते थे तो हम लोगों को बहुत डांटते थे
कि भाई एक साल तो तुम्हारी एनर्जी ज्यादा हो गई, इस साल तुम कम क्यों कर रहे हो। हम लोग हाथ जोड़ के यही विनती करते थे कि सर इस साल पानी ज्यादा आया है तो एनर्जी ज्यादा है।
Pradeep, I'm just trying to give you a picture in perspective. This is perspective planning. Look into the future. Because just one simple thing I want to repeat. जब आपके glacial melting शुरू हो गया है, तो आपका water inflow तो increase करेगा ही करेगा. आपका precipitation भी increase कर सकता है. Because जब आपका ambient temperature higher है, तो precipitation will be faster. What is happening even lower down. So you have to look into the future. Don't be bound and trapped by your present operational things and what is written in your scriptures. You have to do some future planning, which is a great thing. But I mean, I must share with you here before I close that this Terry project, when I was a JS, it may not have seen the light of day if it had not been for an extremely bold decision by the then Prime Minister, Mr. Vajpayee. I approached his Joint Secretary, Mr. Saikia, Ashok Saikia, who's no more unfortunately, a good friend of mine, that इतने हजार करोड़ इस पे खर्च हो चुके हैं प्रोजेक्ट पे, और जब तक पानी इंपाउंड नहीं होगा ये 1 मेगावाट भी नहीं जनरेट करेगा. सो आप फैसला करवाइए पॉलिटिकली, बिकॉज एक आपके मंत्री हैं, आई हैव नो हेजिटेशन इन रिपीटिंग हिज नेम हियर, तो उन्होंने एक कमेटी सेटअप करवा दी थी कि इस वाटर बाय इंपाउंडिंग इसकी जो क्वालिटीज है वही चेंज हो जाएंगी, और जो थ्योरेटिक वैल्यू है, और हमारे जॉइंट सेक्रेटरी उस कमेटी के सेक्रेटरी थे. सो पहले तो इसको जरा डिसमेंटल करिए इस कमेटी को, क्योंकि ये तो आप प्रोजेक्ट को अगर करना है तो इसको तो बंद करना है पानी को. में तो दे वेंट टू द हाई कोर्ट. नहीं, वही तो नहीं, वो उससे पहले ही गए हुए थे. नहीं, वो उससे पहले ही गए हुए थे. वो भी आपको मैं बता देता हूँ 2 मिनट कि वो फिर उन्होंने क्या किया कि वो कमेटी क्वाइटली वो करी, और जोशी साहब का इलेक्शन था, वो परे करके द प्राइम मिनिस्टर सेड कि नहीं, वी हैव टू गेट दिस डन. And who will get it done? The district magistrate of that district. She was a lady that time. She has to stand there and get the tunnels closed. First one set, then the upper set, which he got done. But in between जो शाही साहब कह रहे हैं कि जो टेरी का केस था सुप्रीम कोर्ट में लगा हुआ था, हर टाइम पेशी पे पेशी जा रहा, जो कहा जाता है इस प्रोफेशन में. एक दिन सडनली ये मेरे ख्याल डायरेक्टर हमारे राजीव शर्मा थे, ये डिप्टी सेक्रेटरी थे, प्रॉब्ली डिप्टी सेक्रेटरी थे दैट टाइम. तो उनका मुझे फोन आया कि सर वो केस आज हियरिंग के लिए लग गया और जजेस कहते हैं हमने तो हियर करना. तो वहां क्या हुआ कि रोहतगी साहब हमारे एएसजी थे, शायद एडिशनल एसजी, तो इन्होंने ये आर्ग्यू कर रहे थे. जब वो ऊपर नए सोलिसिटर जनरल अपॉइंट हुए कि कौन, वो बैठ गए. उन्होंने कहा गुजरात से थी कि मैं करूंगा इसको आर्ग्यू. तो वो कोर्ट में घुस के रोहतगी साहब ने अबाउट टर्न कर दिया और वो चले गए. कहते इनके बोलते हुए मैं नहीं बैठूंगा कोर्ट में. सो देन रात को उनको ब्रीफिंग उनकी कोठी पे जाके चालू कराया. फिर एनवायरनमेंट मिनिस्ट्री ने हमारे ऊपर रोड़ा लगा दिया कि इसका एनवायरनमेंट इम्पैक्ट क्या होगा, इस चीज को आप स्टडी करिए. तो द नेक्स्ट डे वी हैड टू टेक अ स्टैंड, and virtually on our feet without consulting anybody, we said give a recommendation that if there is such a problem, the secretaries of the 2-3 departments, power, environment, water resources, and one more department I forget, that committee will oversee this thing, make the statement. वो statement किया कोर्ट ने. They also look for an escape clause. उनका साहब ये ठीक है, इसको चलो आगे इसको चलाओ. तो you see, these are, you've got to think on your feet. What I'm only trying to say कि आप जो आज आपका प्रॉब्लम है, you know the way the deluge is coming. Your water quantities are going to increase. How long? what is going to happen? Whether, in fact, if you do not start planning on reservoirs upstream, also, these structures are not designed to withstand probably that much pressure all the time. You will have to see. And after all, the rock quality, you all see, these are not the igneous rocks of the Deccan Plateau. These are different kind of geology. So you've got to trap the water in the upper reaches wherever it is possible. Now, there again, you see, there was that gentleman who went into fast unto death. So I had taken over as secretary. Few years later, PM की वहाँ कोई ये ट्रांसमिशन क्या कुछ का उनका बटन दबाना था, तो पीएम ने कह दिया वो अपने प्रिंसिपल सेक्रेटरी को कि इनको ले जाइए पावर सेक्रेटरी को, वो लोग हंगर स्ट्राइक पे बैठे हुए हैं, इनको प्रोजेक्ट बंद कराओ. मनमोहन सिंह जी आ रहे थे तब तक. We said nothing doing. शिंदे साहब की कोठी पे मीटिंग हुई. I said nothing doing. The principal secretary said he's a hard-boiled egg. I said yes, I have a bald head, but it's like an egg. But well, you need political support, but we also, you see, your inputs as technical people will have to have the foresight to see into the future. With all this great work done, this is a continuing process. It's an evolving process. I'm so glad that this discussion
So I
is
will add
taking
one
place
thing,
today.
what you have told, it is okay. You see, for the flood moderation and other things, 1 in 10,000 year frequency flood has been taken into consideration for the design of the spillways. So in 1 in 10,000, this is not in even 1 in 100 years, what flood has come. Because 1 in 100 years, 1 in 1,000 years, 1 in 5,000 years, and 1 in 10,000 years, the 80 years hydrological data was taken and then extrapolated for 1 in 10,000 years what flood can come, and the spillways has been designed.
So this is fine. It's an endless debate, but I may tell you that जो जिस एक्सेलरेशन अब हो रहा है, वो जो पास्ट स्टडीज हैं आपके, उससे ज्यादा एक्सेलरेशन हो रहा है पानी का डाउनपोर का. और आप जो बात कह रहे हैं, वो जो स्टडी, गिव यू एन एग्जांपल ऑफ द अपर बारी दोआब कैनाल का जो हेडवर्क कोलैप्स कर गया, क्यों कर गया?
वो छोटा है ना.
Let's get back to PSP.
Yes, sir. Yes, sir.
PSP. In the general discussion, Tehri has a lot of stories, so forget about that for the present. PSP operation is not fully understood to all of us. Let's get back. Today's subject is PSP, and in that context, let's get back to PSP. This PSP, your PSP.
Yeah, sir, this is our.
Quite often, or more often than not, you are running at it because you have water and you have level. You are running as a normal project. Yeah. So, what is the possibility? How is this the character having the characteristic?
4 months in a year, you will be operating at least 1 or 2 machines, at least 20 to 24 hours. So during that period, you will not be able to operate the PSP.
Yes, sir. Yes, sir. That is true. That
Means it will
that
be
is
available
technical
on-
limitation, sir.
Maximum.
And one more thing, sir, I would like to submit before this big board, sir, because thank you very much, sir, for your even earlier contributions, because Shahi, sir, and you are highly incremental. One thing, sir, basically when we generate through UI, this is unscheduled. The regulatories don't pay anything, sir. That is a main, we have been asking all the time, because whatever regulatory, whatever this NRLDC give the schedule, out of that, during monsoon season, we get only 20 paisa per unit against unscheduled generation. So that even doesn't not cover the even O&M of expenses of the machine. So we are clear it does not cover. So that I would like to, in between, to request this forum to take this matter, because reservoir, wherever reservoir projects are there, they would be facing the same difficulty during monsoon specifically. Please continue.
I would like to add something.
regarding the operation of PSP, definitely philosophy of the operation of the PSP is very, very important. Initially, our PSP was designed to operate for 9 months only. During the monsoon, it has to work as a normal hydropower station. And during the DPR stage, the input, the only generation was available 1268 million units, and for which the 1712 million unit was to be pumped. The overall efficiency, it was planned in a one cycle operation. The pumping was planned with the thermal power available during the night hours, and of course the generation during the peak hours. So it was not planned. Now, as per the changed scenario with this RE, the integration, the operation philosophy has been optimized accordingly. And even to meet this monsoon period requirement, it is still planned that during the monsoon period, whenever we have surplus water, it will be worked as a normal generating station for few days. Of course, about a month during the out of the 12 months for this. Because this is the only on-stream PSP. This is not the off-stream. This scenario has come up a little later, but this is the on-stream PSP. Yes, non-monsoon period, it will be working fully PSP, but during monsoon, for still, because now it is the RE power is available during the daytime. So we can operate whenever is required, even the 2000 megawatt as a generation when it is that there is the main. And even
while commissioned, during commissioning, how many hours you operated in the pumping mode so far?
Sir, we have operated.
No, but then commissioning means what?
Pumping. Sir, we have operated 7 hours in pumping and 6.5 hours in generation mode during commissioning. No, sir, we didn't face any kind of problem. Yeah, 7 hours. Not so far. Sir, during testing, and also after commercial operation, also we have operated this plant in 7 hours in pumping.
The commission, we will know the experience after some time, how it this non-monsoon it operates as Okay. So let's take another.
Civil side.
Sir, thank you. Okay, sir, we thank you, THDC Executive Director, and for giving a very elaborate presentation. And I think we have had a lot of discussions with the former both secretaries, and it was a very lively discussion. And we once again thank you. And we proceeding further, sir. We would request Mr. Parveen Nanda, the Executive Vice President, Greenco, now to give his presentation. Mr. Parveen Nanda has over 30 years of experience both in government and the private sector in the renewables and related environment industry from concept to commissioning. His key working areas have been the project management, procurement, engineering, strategic planning, construction management, and business development. He is an engineering professional, graduated from National Institute of Technology, Allahabad, and postgraduate from NIT Kurukshetra. We now the floor is with Mr. Parveen Nanda. Kindly go ahead.
Can we display the presentation also? Just sent.
Presentation.
अभी भेजा मैंने WhatsApp पे. So by the time presentation comes, I think I'll just brief it, sir. So we Greenco, sir, we are a renewable energy company and we are in a big way into the renewables. As of now, we have almost 10 gigawatt of renewable sources, solar, wind, and hydro put together. And I'm proud to announce that we have fully commissioned that 1680 megawatt PSP, off-stream PSP now. 28th August, we commissioned the last machine. So it's fully 1680 megawatt commissioned PSP now. It's running in operation since mid of June. We started first machine operation in mid of June. Our story is totally different than the story of Tiri, because the parameters and the conditions wherein we were trying to work and explore the possibility of PSP was altogether a different mind game altogether, sir. When we started thinking of building a PSP, at that time we thought that round the clock renewables is a phrase which might hit everybody, and everybody might look to go for round the clock renewables. So that's how we conceived our PSP Pinnapuram 1200 megawatt with 9 to 10 hours of storage. And we conceived the idea of using variable speed machines. We thought that round the clock renewables, when we are talking about, we need highest flexibility, so we have to go with the variable speed machine. So that is how we conceptualized our project at that point of time. But the moment we started going for the PPAs and other things to the market, we realized that the market needs are altogether a different game. So the market, what was looking at the market was that market was looking for only peaking power kind of situation. They were not looking for 9 to 10 hours of storage. They were looking 5 to 6 hours of storage. And at the same time, when we conceptualized, we thought that the market fulfillment needs of the contract might be more than 95%, because we are talking about RTC, round the clock renewables. But again, we realized that the market needs are altogether different. They are looking for less than 85% of the fulfillment. They are not looking for more than 95% of fulfillment. So our requirement changed from RTC to picking power, 9 to 10 hours to 5 to 6 hours. And then the fulfillment needs less than 85%. That's what the market demanded at that point of time. And again came to the flexibility. Flexibility dropped down from high to moderate. And now when we thought that the requirement is less than 85%, it is peaking power, then is it useful to go for a variable speed machine? So then we thought about a lot of things, how to accommodate the flexibility also into the system. The first alternative was use fixed speed machines and use small quantum battery also. So that was the first thought. We did a lot of studies. We converged to a specific requirement of the battery which was to be used. But then we came up with the innovative idea of using two sizes of machines, 240 megawatt and 120 megawatt machines. And to use the machine is hydraulic short circuit. That means that one machine runs in the pumping mode, other runs in the generation mode, so that the net output power either as absorbing or generating can be controlled. So we realized that this combination is as flexible as variable speed, almost, not fully, but almost. So that is how we innovated that idea, and that idea was implemented. And then we withdrew the idea of putting a battery in the system, and then we went ahead with the 240 and 120 megawatt machines. So that is how the conceptualization of the project changed. What was the thought of scenario and what is the practical scenarios. So that is how we converged into that. And we started this exercise as early as early 2018. This conceptualization of project was started, and all these cycles. And that time the policy was not at all there, I can say. And now it is almost to the 90% or 95% level. We have policies in place. So we had to struggle everywhere, every location, convincing the viability of the project, suitability of the project, effectivity of the project. But somehow we got support from all quarters, and we could move ahead at a very fast pace. And by the time we were in a position to reach the groundbreaking level, the COVID struck the country, and then again we were put on a hold. At that point of time, we thought that we were actually trying to put the project in place. So we realized that the scheduling of the project and the contracting of the project is as important as implementation of the project. Because in this particular case, the electromechanical segment of the project is a longest duration lead item, more than the civil item. So even while the COVID was at the peak, we awarded our E&M contract to Andritz, so that they can do the engineering, they can be ready with the model test, and they can complete that process of model test, which is 9 to 10 months of requirement before we start physical construction at the site. So that is how the strategy was changed for that project to be implemented. And once the model studies were completed, we were still in the phase 2 of the COVID when it was going on. So we thought now it is the right time. We cannot delay it further. We have to start the project. And then we started the project. And for starting the project also, there was so many support which we got from the various statutory authorities in the country. I must spell out here, because to make a a mega project successful, it was not possible without their support. First support came from the CA side. Because of COVID, the people were not able to attend, they were working online rather, and the concurrence was getting delayed. Then CA came up with a wonderful idea of allowing excavation activities prior to grant of the concurrence. Because the layout was approved, designs were almost in the 50% stage checked, so they allowed the pre-construction excavation activities. So that was the first step, landmark decision for the first time in the country. Then came the second decision from the forest department. Because of COVID, the people were not coming for the registration of the lands, revenue authorities were not present in their offices, and then came the forest department into the picture. MOFCC took a bold decision that we will divert the part forest land and you can start the activity of the critical work, that is powerhouse area. So we could register half of the land and they allowed us half of the forest area to be diverted for the project that was near the powerhouse area, which was most critical. So that was allowed to us. So we started with that part. Third, EC environment clearance takes its own time. Public hearing we could do well within the COVID time, but still there was a lot of hiccups coming. So they also came up and they supported in expediting the clearance process, doing everything online, and eventually we got the clearance. And fourth came the state government support, because it was phase 2 and the COVID was at peak, and the mobilization of equipment and mobilization of staff was a lot of issue. They were not allowing aggregation of the people, staff, construction workers to the site. So government came up with the support and they provided all paraphernalia infrastructure to allow us movement of the equipment from all places in the country to the site, and we could start working at the site. So all these 4 major steps which were there from the government support, we could start the project in July 21. We started the project. So then came by the year end, December, January, then came the third phase of the COVID. So almost first 16 months of the project, we were doing construction during the COVID period. Though we could made a substantial progress, but definitely it had an impact on this in the execution of the project. Now I'm coming basically to the point that how did we conceptualize this project? When we started conceptualizing this project, actually idea was not to make a most economical project, but the idea was to make a most useful and constructible project. The idea was because at that time the hydro image was going so badly down to the, I think we have to move a little bit up now. Slide adjustment, slide, half of the slide. Go to the next slide now. Yeah. Sir, I would say that this Pinnapuram PSP is, no, next slide, next, bottom, next slide. I'll move from here. Next, yes. So I would say that this Pinnapuram project is not the most economical of the PSPs, what we call the PSPs. But the idea was that let's create an atmosphere of confidence in the hydro industry at that point of time. So we chose the project which was constructively the most suitable project at that point of time. CTU connectivity was close by. There was no RR issues involved. There was no environmental issues involved in the project. Accessibility to all sites were readily available. Solar project was just nearby. We had our establishment there right at that place available. And it was an off-stream project. Water source, dependable water source were available close by. So out of the 5-6 projects which we had identified at that time, one in Karnataka, another in MP, one in Maharashtra. So we thought that best way is to go this project and infuse the confidence in the industry that the projects can be built faster and can be built in a better way. So that's why we went ahead with the Pinnapuram project. And eventually we have completed the project in exactly 1 year, 4-year period, wherein the 14 to 16 months were in the COVID time. So we have been close to our idea of completing the project in 36 months. That's what the idea was. So this is the thing which I've showed, that support we have got from the government on all 4 issues that I have listed here. So now, sir, features, I think this is a small head project. The rated head of this project is 122 meters only, sir. But here I would try to say few things regarding the. Yes, sir. Yes, sir. This key initiatives during the planning, sir. For PSP, it's very important, sir. Once we conceptualize the PSP, the purpose what we are trying to serve is very important to be to be identified, and accordingly the project is to be conceptualized. So when we came down to idea of fixed speed machines and two-speed machines idea, we reconfigured the project entirely. We adjusted the head variation in both the reservoirs to a value we get the maximum output of the machines in that. Because in fixed speed machines, the efficiency curve drops down badly once you go down to a larger head variation. So the adjustment of reservoir head variation was adjusted accordingly. Then the surface powerhouse. There's a lot of debate on surface and underground powerhouses, but we opted for surface house because that squeezed the period of construction by almost 12 to 14 months. Dam heights were optimized to make them easily and affordably executable. Machine sizes were maximized. We rarely see 120-meter head and we see 240 megawatt of machines. So we optimize the machine sizes so that the project is very compact and very effective that way. Then for the erection, we say two level of erection base, one at the higher level, another at the lower level. So by the time we are reaching downside, we are able to start fabrication of the equipment on the higher level erection bay also. Yes, sir. Like we stator, rotor, and MIVs were at the lower level service bay, but all other fabrication was happening at a higher level of service bay, and that was connected with a shaft EOT to the bottom. And then hydraulic short circuit provision, which is in existence, but we try to use it extensively for this project to increase the flexibility of that. And then came the safety aspect of the powerhouse. Because it is a deep pit powerhouse, PSPs are deep seated, so it's a very deep pit powerhouse. So for the safety, then we ensured that we have a MAT approaching the service bay also, and at the same time we have a surface access also, road running right up to the service bay, so that we have a two-way access, and in case of any exigency, the evacuation is possible through two-way area. So safety was also considered at that point of, and early award of E&M works, as I specified, that was one of the main areas. Then came the innovation during the construction stages. There were a lot of things which were done, but few to list which we did during the innovation was that we opted for geomembrane based rock-fill dams in this area, which was first of its kind in the country because they had not done anything in the country. These are very durable and very fast to execute type of dams, and now most of the developers are opting for these type of dams only to execute because they save almost 6 to 8 months of the construction of the dam embankment period in that period. So then another aspect which everybody is scared of in hydro is the geological uncertainties and the readiness. So that is the area where we thought that we should be ready. Though there was no need of cable anchors in our project area requirement as per the geology report, but still we mobilized the contractor and we kept it ready that in case of any emergency because of deep-seated powerhouse, we might need it. And eventually we needed it and we could take a decision in shortest time of 2 to 3 weeks and implement without affecting the project schedule. So that's how it helps us in getting the readiness for the execution of the project. And then came, sir, once the civil works were completed, E&M works were in place, then the commissioning process was to start. There's a lot of time required for filling of the off-stream reservoirs because you can't put 100 megawatt or 200 megawatt pumps to fill up the reservoir. You can put 15, 20, 30 megawatt pumps only. It takes from 90 days to 180 days to fill up the lower reservoir. So we isolated our lower reservoir by putting a temporary coffer dam so that the filling of the lower reservoir is happening simultaneously while execution of the E&M works readiness is going on at that time, sir. So we could take another 3 to 4 months of period of filling the reservoir and simultaneously the E&M and powerhouse readiness was going on, sir. And then came the commissioning activities, sir. Because we had almost 10 kilometer long of the embankment line for the reservoir. So grouting was taking a lot of time and it was trying to control the period of the project. So then again, we thought of an innovative situation. We cordoned off tail race and upper reservoir partly and started commissioning activities, testing and commissioning in a smaller water quantum. We did that activity. So this was again an area where we could save almost 6 to 8 months in the entire sequence of the project. In case of erection also, sir, the biggest advantage we took of the service powerhouse was that we used mobile cranes for erection of equipment. Right from the draft tube to the steering, we use 650 metric ton crane to install the draft tubes in the steering process. That's for one point. Then we, on the designs part also, we use single shaft. For such a big machine, I think this is first of its kind incident in the country that we are using single shaft for coupling of generator, rotor and the turbine. And then the third innovation we did was with a contribution from the E&M side also. We used pre-assembled stator segments, sir. So the stator assembling period was reduced by almost half by getting the pre-assembled stator segments. And then taking up 2 to 3 machines of commissioning, assembling simultaneously. So normally, the vendors are reluctant to put more than 2 teams at site because they don't have that manpower. But practically speaking, it's hardly 2 to 3% of additional cost to put a third team into the place, which saves a lot of time and energy, and the commissioning happens fast. So these were the few things we did in the process, and we could, with all these innovations and efforts, we could complete the project in 4 months, 4 years time in totality, sir. So now we have all commissioned the project, and since we are running since 15th of June the project, and project is running well, sir. So we are running all operations, pumping and generation, full cycle daily.
Can you give some input on the operational side?
Sir, operational side, sir, we see this is a co-located project, sir. This is a co-located project. So we have a solar, wind, and PSP all in the same location. As of now, as per the plan, we have to have almost 3550 as the renewable energy for the project, and 1680 is the PSP component, sir. All put together, 5.23 gigawatt project, sir. As of now, 2000 megawatt of solar and 250 megawatt of wind is already erected at site. So that is being used for the pumping power, and rest of the power is being taken from the grid for the pumping operation. Yes, sir, we are getting outcome as design, sir. And such few issues come up, like SRLDC had some queries on the area capacity. So what was the designed area capacity and the practical area capacity? There is marginal variation of 2 to 3% because to save the land, we do a lot of construction activity within the reservoir also. So that doesn't matter. So they wanted to be very precise. So we have repeated, we have done it to them. And it took almost 15 days, delayed the commissioning of the last machine because they wanted to confirm before that, whereas it was not important as we were thinking it was. So there were a few hiccups in that process, but we still could do it.
Remember, what is it?
So there's a Gorukula reservoir, balancing reservoir in the irrigation system. We took water from the Gorukula reservoir. Gorukula reservoir.
Excellent, sir. Just 2 quick queries. One is, you see that you're operating in a different kind of terrain as compared to North India or East India. You chose the best technology. But on the type of machines, I thought, if I got it correctly, that you would go in for what kind of technology. One of the parameters that helped you base that was some market research that you did. I think a parameter where you said 85% or something was market demand. Now, market is a variable. If you fix your technology based on today's assessment of a market, will it hold in the time perspective or no?
Sir, the selection of type of machine was with reference to the flexibility requirement. And these machines are as flexible as variable speed machines, with a marginal difference, definitely. Variable machines will still have some black spots also. These have slightly bigger black spots than the variable speed machine. But this machine is flexible enough to cater to any needs of the future as well. So when we were thinking of project to make 1200 megawatt for 10 hours of storage, we were trying to supply RTC power. That I can do still, sir, because if I need a RTC supplier, because that rates and that agreements will be at a different price. So I can still use my project, stop 2 machines, work balance machines 1200 for 10 hours. So the project can be suitable for any kind of need. And sir, I must specify here, sir, India is a solar intensive country, sir. So in this solar intensive country, we will always need projects with more installed capacity and less deliverable capacity requirement. The installed capacity of machines will be high because we will be required to absorb lot of power during the day, 6 hours, but the need for the generation requirement will be much lesser. So the projects will require to be conceived with a higher absorption, less dispersion. So this project futuristically also fits into that requirement, sir. I can absorb 1680, but I can disperse any amount of power, 1200, 960, whatever is required to be done. These are reversible, sir. Reversible turbines. Little query on my ignorance. You see this, you mentioned that's your geomembrane based sealing system for the dam. What exactly is it? So this is a PVC based product, sir. This is specifically designed for the water retaining structures. We make a rock fill dam. We can put a surface sealing of many types. One is concrete faced. We put concrete slabs in that. Second is asphalt facing. We put bitumen surface on that. And third is this bitumen based surface, this PVC membranes. So concrete faced rockfill dams are quite popular, sir, but they have their problem because these rockfill dams have a tendency to settle. They will settle over a period of time, sir. So there are a lot of cracks which happen on this project. Now, if you are making an off-stream project, water is a pricey element for you because we are buying it at rate cost from the government, sir. So any loss of water is a price to me. So I cannot afford that loss once the dam settles and there are small frictional micro cracks and some water starts seeping. Asphalt is an issue, sir. Asphalt facing also, there is no dam in the country as of now. We tried asphalt also. We engaged one of the best contractors, Valo, from the Switzerland for that matter. But since they are patented to some extent to their technology, they were trying to blackmail us and bulldoze us for the higher costs. And then we took this third route, which was geomembrane based dam. And these dams have a history of more than 60, 70 years in the Europe and America. They have already bitten, they are standing good with those membranes. So this is a membrane, a PVC membrane, you can say. It's a PVC membrane with a specific composition, which is UV resistant also. It has another component of plasticizer in this, which sustains its properties, tensile, puncture, and all other properties for a longer duration, so that we can have a life of more than 25 years to 50 years. Okay, you see, if it was used earlier in Europe, or has it been used in tropical countries? Yes, sir. Yes. No, in tropical countries also. Yes, sir. Yes, it is being used in tropical countries, and because you see, destruction of that material that you're talking is more temperature related, and if there are higher temperatures, those membranes could disintegrate. No, sir. In rocks or no? In the very high temperatures. Sir, it is equally susceptible to cold weather also, sir. The shrinkage is as troublesome to those membranes as the hot weather also. I see. So now, once we do the testing of this material for installation, we do aging test on these materials. Sir. What we do is that we, through xenon lamps, we expose these membranes for 3,000 hours, 10,000 hours, 12,000 hours at a much higher intensity of UV, what we are going to get it. And then we see what is the loss of properties of those membranes. The properties which are physical properties which are important for us, tensile strength, elongation, puncture strength, etc. And that after that exposure of 10 to 12,000 hours on a much higher intensity, 30 times, 40 times of our UV values, then we adopt this membrane once it qualifies that test also. UV sealing or is it normal sealing? These membranes have a content chemicals which are UV resistant. So we invariably we need UV resistant because these are exposed to the sun.
You said you commissioned the plant in June this year.
June we started first machine. And
how many hours a day were operating the PSP?
So we are operating because initially we had more water, less machines were commissioned. So we were almost generating 9 to 10 hours in the generation mode, and pumping was 7 to 8 hours a day, sir.
And he was a composite power purchase agreement or separately for PSP and others?
Sir, we have different kind of agreements for us. Sir. We have one agreement with SECI, wherein we are supplying them 900 megawatt agreement with them, wherein 450 is to be supplied to the PSP, sir. And rest of the solar we are to supply at a separate rate to them all during the day. Second agreement we have with the ArcelorMittal, sir. We are supplying them RTC power for their steel plant. And we are having some component of the power which we are supplying as of now on the merchant. But later on, that power is to be used for our hydrogen plant only, sir, which we are putting up in Kakinada. Yes, sir. Green ammonia plant we are putting up in Kakinada. So once the plant is commissioned next year, we will start using this power for the ammonia plant. As of now, we are sending it merchant in the market. The generation has been in the peak hours only, sir. From 5 p.m. in the afternoon to morning 2 to 3 a.m. in the morning, sir, the generation. And the pumping has been from 8:30 a.m. into the morning to 5:30 in the latest in the evening time, sir.
See, between variable machine, variable speed machine and sizing of unit and number of units, you seem to be in favor of sizing of units or number of units rather than variable speed machine.
Sir, actually,
This is what you said.
yes, sir, yes, sir.
Instead of
Yes,
variable
sir.
speed machine.
Sir, after that, once we done, we did this part, sir. CA took up a big study, sir, to see that what kind of mechanism should be suggested for the country to adopt, sir. They studied variable speed machine, they studied fixed speed machine, and they studied this model also, sir. Eventually, see that report of the CA that also concludes finally that the two sizes of machine is a best suitable composition for adopting. Yes, sir.
Now, another thing is that in one discussion somebody raised, right, that when you give power from solar to this is when you give power to your from the PSP. In transaction, does it require GST?
Sir,
Whether a question was raised in one of the discussions that
sir, actually, there is an ambiguity in that, sir.
there is
We are
ambiguity.
still in discussion.
And
with
the question was, I
yes,
should have raised this question with
yes, sir, yes, sir, yes.
Ghanshyam. That
So I think it's
in
going
this
to be
case, in battery storage, because you see, what is needed is that all these backup schemes to support solar require some degree of support. If you treat it exactly as sales, purchase, etc., because it should be like auxiliary power consumption. In a thermal power station, you use that as auxiliary power consumption. That is not treated as sale of power.
so whatever we are using internally, sir, co-located behind the meter integration, there is no issue, sir, because I'm supplying only one product out from either project. But when I'm drawing power from the grid for that, there the issue is coming up, sir. No, then there is no GST on that. Yes, then there is no GST on that.
You are very right, sir. Prasad साहब, that इसमें हमें स्पेशल कोई देना पड़ेगा डिस्पेंसेशन, अदरवाइज एंटरप्रेन्योर तो बेचारा वो तो वेरिएबल स्पीड मोटर के बजाय जो वेरिएबल टैक्स स्ट्रक्चर है उसी में फंस जाएगा.
Yeah, first compliments to Green Co team for commissioning
Thank you, sir.
PSP plant of this size in 4 years' time. What, in your view, is the most optimal use of optimal mode of operation of PSP as a standalone PPA or round the clock power?
So I think both the operations will be in need of the hour as we go down 2030, 32 beyond, sir. So as of now, the RTC needs are quite less because we have a lot of other sources of power in the system. But going down 2035 and beyond, when we start backing down the thermal power projects, at that time the RTC need from the PSPs will grow, sir. So that's why we have a thought process that all this thinking which is there in place now, everybody is making 5 to 6 hours of storage PSPs, might not be the right way to go. We have to have some percentage of projects which should have storage more than 9 to 10 hours in that. So that
And operating in standalone, that will be most.
that, that will be most optimal at that point of time, sir. Yes, sir.
Excuse me, sir. I have two questions. What is the efficiency of your fixed speed machine now which you are getting? Now we have some time of operation. So what is the average losses which you are making? And number two, if you could have considered a variable speed, what would have been the cost difference?
Sir, I'll come to the second question first.
Yeah.
Variable speed was costing us almost 1.8 times the fixed speed machines.
1.8 times.
Yes, sir. 1.8 times, sir. At that point of time, that was 1.8. Finally, it was negotiated and it came down to 1.65 times. But nobody was coming beyond that difference. Mega, sir. First point. Second point, sir. The cycle efficiency, which why we opted, I'll tell you 3-4 reasons why we didn't opt for the variable speed machine. Second point is the cycle efficiency of the fixed speed machines is higher than the variable speed machines because of the auxiliary consumptions in VSI and other things. Third point, which was more controlling our choice of features, Nobody is ready to give the availability of the machine 95% and above for the variable speed machines. They give 90% and below availability because they are not sure of its operation round the clock, round the year in an equitable manner. So when we talk about for the 95% of the plant availability, everybody backed out of the ideas. So these were the three major criteria which prompted us to go for fixed speed machines and then to innovate two sizes of machines to have equal flexibility.
You have two different machines?
240 and 120, sir.
240
Just to
and
have a
120.
symmetrical pen stocks,
Okay.
we made it half the size.
All the machines?
Two are two machines of a smaller size, rest all machines of
Now,
bigger
this is
size.
also a great idea that you are keeping the size of pin stock same.
Same, yes.
So 50-50 आपने कर लिया.
Yes, sir.
तो ये भी
Yes, sir.
बहुत अच्छी, हाँ,
Yes, sir.
ये बहुत अच्छी बात आपने बताई.
Yes, sir. और उसका एडवांटेज क्या है सर कि मेरा जो शॉर्ट सर्किट है सर वो शॉर्ट सर्किट हो जाता है सर.
नहीं, वो
स्मॉल शॉर्ट सर्किट सर.
बिल्कुल,
I have least possible losses in that.
Great.
So this dam is an embankment dam. So the core is impervious, and you have put an additional geotex, which is PVC membrane over it, the geomembrane. So it is the additional factor of safety kind of thing, or the dam?
No. Most likely there is no core. I don't know.
No, it's not. There is nothing the factor safety in this. See, the dam stability is a separate aspect.
So the core is
This
there
is
or
this
not?
is basically to check the water ingress into the rockfill dam, which impacts the. So these are not central core dams. These are surface ceiling dams.
Okay, so the only impervious thing is this geomembrane thing which you
Yes,
have put on the
yes,
surface.
yes.
And what after the life of 25 years of this?
And normally, this projected life is 50 years.
Okay.
Only thing is that guarantee given by the suppliers is not beyond 15 years or so. But we do, that's why we do that rigorous testing of 12,000 hours. Normally recommended is 3,000 to 5,000 hours. But we did testing up to 12,000 hours to have that surety that this is working for 50 years. As I said, there's a component of plasticizer in this.
Okay.
That plasticizer is a component which degrades with the UV radiation. So every year we'll keep monitoring that plasticizer percentage. It starts with 35%, and if it goes below 17%, then you start getting impact on the physical parameter. So over a period, we'll have that assessment. So by the time our plasticizer assessment is coming to say 20% or so, then we'll realize that there are another 3-4 years for us. Then we might need to replace that membrane at that point.
So how we will replace? It is on the surface of dam?
Yes, sir.
It is lying exactly on the surface.
Then in that case, sir, we have to apply one reservoir at one time and replace it.
See, ये जो आप UV का वैसे my impression was UV is used for sealing these components.
No, sir, UV.
Sealing नहीं, but आप कह रहे हैं ना कि UV से वो degrade कर जाएगा.
Yes, sir. It's any sir PVC material when it is exposed to UV, it degrades. Now
पहले तो integrate करेगा.
नहीं सर, UV डिग्रेड करता है सर. सनलाइट सर, सनलाइट जो है सर,
not the artificial.
No. I'm talking about the UV radiation from the sunlight, sir. That degrades the materials. Yes, sir. It is imported as of now, but now there are a lot of manufacturers starting in India as well.
Who is the supplier of it?
So we use the leading person Carpi for this.
No, not this product.
Yes.
All your equipment.
Entry cells supplies. Entry supplies.
Sir,
Sir, 3.5 mm. 3.5. सब जगह use है, sir. That is non-UV, sir, because that is sandwiched between the concrete, so that is non-UV.
all right.
I think last presentation.
One question.
Yeah. Thank you very much, Mr. Parveen. You had given a lot of technical innovations which have been provided into this project. And it's a very good presentation by you. And the discussions also, for clarifications also, you have really given all the answers which were desired in a very technical manner. And thank you very much once again. And we come to now the next presentation by Mr. V.S. Rao. He is General Manager Hydro of Bharat Heavy Electricals. He has more than 33 years of experience in the field of hydro power product in BHEL. And he has been working in the field of hydraulic design of turbines, high capacity pumps, pump turbines, numerical simulation using CFD, hydraulic transient studies, design and manufacture of hydro sets. He has authored many technical papers also in national and international conferences, and is a member of the national committees in the relevant area and holds 6 patents in the field of hydro. Over to Mr. V.S. Rao. Thank you.
Thank you. Thank you, sir, for a generous introduction. Respected President IEF, Shahi sir, Bajaj sir, Mahajan sir, Sharma sir, all distinguished dignitaries present here today. We are privileged and we really thank IEF that they have given us an opportunity to present our view with regards to pump storage and what BHL is doing for gearing up. Good afternoon to you all. Sir, my presentation will be a brief one, and I hope to bring variety in the sense that it will be a manufacturer's perspective rather than we have been listening to two owners. Now it will be a manufacturer's perspective. So just as an introduction, we actually, it's indeed a privilege to be speaking on a subject which is core to the India's transformation, India's energy transformation journey. As Chairperson CA clearly told, that we are into that phase of energy transformation. When we look forward, basically we are on crossroads. There has been unprecedented increase of renewable solar and wind in the recent years, much beyond what we had expected, but that has been a boon because it gives us it has given us energy surplus situation. It has given us a position where we can think of expanding further and cutting down our fossil fuel generation. But simultaneously, it has brought on the table issues like grid reliability, stability, fluctuation of grid, providing inertia to the grid. So in that context, hydropower and pump storage both are the most viable options as of now. And we have also been looking into this and seeing this coming. So we had started, sir, actually, just to brief, sir, we had started almost 8-9 years back this development and all processes. And presently we are in a stage where we can offer any PSP of any rating which is being foreseen in the country. Just next slide, please. Just I thought this would interest the audience. Global energy challenges are known. Energy demand is ever increasing. Dependence on fossil fuels is creating disadvantage in terms of climate change. Transition to renewable energy is a global phenomenon, and almost 130 countries have maybe promised net zero at some point of time. So renewables are going to increase. So that brings the requirement of grid storage. The graph below, if people can see, probably not see, but I will explain. Shows how grid storage is being done presently. Presently, at the point when we are speaking, as per open data source, more than 90% or maybe 95% of energy storage is being done through PSPs. That is grid scale storage. Presently in the world, around 190 gigawatt of pump storages are there. By 2030, it's expected that this will double. China itself is planning to add 120 gigawatt till 2030. India, as Chairperson CE said, have a target anywhere between 53 to 60 gigawatt till 31-32. That means in the next 7 years. So what we are saying is also projected there is in the other curves, the reddish one is how the other conventional grid storage capacities are going to. This is just a projection. So the below one is vanadium based redox flow, which is the upcoming technology. So that is going to no, backs. That is going to pick up, and the bottom one is lithium ion energy storage. So, but the top gray, bluish gray is our pump storage, and till 2060 itself, also we have pump storage will have the major role as compared to other grid storage solutions. So this is picked up from an open source, which could be of interest to all people who are working in fraternity of pump storage. Next slide, please. Thank you. With respect to Indian scenario, we have an installed capacity as of July 25, 490 gigawatt, CEA figures. Hydro is around 10%. That is large hydro. And thermal is 50%. And as Chairperson CA just now told, we have an ambitious target of 214 gigawatt of PSP potential, out of which off-river and on-river was being discussed vehemently. So off-river is like 156 gigawatt and on-river is 58. So mostly it is off-river closed-loop systems. Next, please. As we all know, global scenario, hydro constitutes almost 16% of world's total electricity capacity, installed capacity. Whereas in India, as we saw in the last slide, it was 10%. Our government is, and both CE and government are taking steps to ramp this up very quickly. The benefits of hydro are known to all, so I will not be dwelling on that. Benefits of pump storage is also known to all. It's a grid scale, reliable, established technology, and where we can be using it for on a day-to-day basis or for round-the-clock renewable energy, or even periodically as and when it is required by the grid. So the important functionality is it also provides inertia, much needed inertia to the grid, which helps in evening out fluctuations of the grid. Next, please. Just a comparison, if we interest people, how pump storage and battery storage are placed against each other. But I must say that there is a lot of research which is going on battery storages. And as I said, redox flow vanadium is the in thing now for researchers. So, and that is going to be ramped up very quickly in next 20-30 years. But still, PSP will have an edge till 2060, as we could see. Benefit of pump storage, of course, efficiency, I have said, slightly lower, but it's basically in shorter bursts. Battery storage maybe just more efficient, just greater than 80%, but generally PSP cycle efficiency will be 75 to 80%. Lifespan is obviously very high, and the initial cost, when we consider that the battery will be phased out or maybe lost in around 15 years. So this has a fairly big span. The civil works do not require any addition after 40-50 years also. Maybe the machine can be upgraded. Safety wise, it is safe. There is no issue of environmental wastes. So that's a brief which could maybe satisfying for our PSP fraternity that yes, this is going to stay, be the mainstay of energy storage in India and the world. Thank you. Next. So what, as BHL, what we are doing, just an introduction, sir. Probably we do not need an introduction, but nevertheless, I will take this opportunity to introduce. Although there are several manufacturers, since the last 30 years who have built factories in India, hydro manufacturers. Still, we have a healthy installed capacity percentage of 46% in the country. We have already supplied 550 hydro sets, plus 35 gigawatt is under commissioning. That is 35 gigawatt total, but this includes commissioned as well as under commissioning projects. We are leaders in lift irrigation sector in the country. We have made record number of lift irrigation scheme equipment. The biggest, of course, is 145 megawatt for Palamuru Rangareddy, which, when considered for pumping alone, because presently that those reversible pump motors are only being used for pumping, sir. They are not being used for generation, because there is no upper reservoir in those schemes, essentially. We have commissioned almost 3.4 gigawatt of pump motor sets, and another 53, that is 7.1 gigawatt, is under construction and commissioning. This would be of interest to all. Annual manufacturing capacity in Bhopal, our hydro block itself, it's 2500 megawatt per annum, coupled with there is another block in Bhopal which can be used for hydro in case there is a need, and other units like Haridwar or Hyderabad, we can ramp this up to 7 gigawatt per annum, including our ancillaries, dedicated ancillaries. BHL is definitely a one-stop solution for hydropower equipment. We have a biggest pool of engineers dedicatedly working for hydro in the country. We have regions, specialized regions, service groups, 16 manufacturing units. So manufacturing capacity wise, it's mammoth as compared to other players. Next. We also do all sorts of turbines, pump turbines, everything we can do it. Next. This is just an historical listing, how we moved. Just like any classical hydro manufacturer, we started with iterative experimental methodology. It is called model testing. Then we moved to 2D analytical methods, then 3D numerical methods. Presently, we are doing state-of-art, industry standard high-end computation using blade clusters and parallel processes. So technology-wise, we are very much there. And in the past several tenders, there has been no lacking in terms of technology. Whatever is world standard, we have been able to achieve. Next, please. Some major landmarks. This is, of course, mostly hydro. So the highest rating Kaplan turbines in the country is Zukai 75 megawatt BHL vintage. The new ones which are coming is 80 megawatt Polavaram. That also is by BHL. The biggest rating Pelton turbine in the country, 200 megawatt Parvati 2, is BHL. Biggest head in the country, Taming Francis turbine, is BHL. Biggest head Pelton in the country, Paikara, is also by BHL. So those landmarks, we have plenty of them. We have accrued over the years, and we just wish to go big in the PSPs also. We have this is important, sir. We have a state-of-art accredited laboratory, which none of the manufacturers have in the country. All of them have in their parent countries. So this is a center of excellence in Bhopal, especially for development of hydraulic designs of all types of turbines and pumps. It's recognized by DSIR also. Next. This is an experience of PSP. Earlier, erstwhile, when there was these PSPs were new things. Essentially, if you can see the dates, it's October 87, 88, 84, 85. So these are the PSPs installed in the country. BHL has been associated with all of them, mostly all of them, except for two in the past. Only in the new phase, As sir just mentioned that we are yet to get an order and we are moving ahead. In this, I would like to mention, sir, all these PSPs, although they were existing in the country, the machines were existing, but the owners rarely ran it in pumping mode. They were always used in generation mode because our country was always power deficit. There was probably no opportunity for the owners. And in many cases, like Sadar Sarovar, Kadana, they do not have a lower reservoir. A PSP will essentially have required two reservoirs. They are PSPs. No, they pump storage. PSP. No, yes, sir, it is PSP. They did not have a downstream reservoir, sir. Basically, two reservoirs required. For generation, only upper reservoir is required. For if you want to pump it back, obviously you have to store water in the lower reservoir. So Sadar Sarovar and Ghadgar, Kadana. Two projects, on one left bank and one on right bank. Sardar Sarovar also 6 into 200 is PSP. No, no, sir.
As far as the project running is concerned, because there is no lower reservoir, so
the machines
there is
installed
no
are
storage of the lower
reversible
reservoir.
pump. Yes, they can do that.
Here they have made the dam, like Terry itself, 1,000 around. So this dam have the head, and then you are running the turbine and generator. There is no such pump.
That's what I'm telling you, that the machines are capable of pumping, sir. नहीं नहीं तो अभी लो सर मैं बता देता हूँ अभी अभी मैं बता सर I will tell you.
As they are conceived and as they are constructed.
There is a sir. Can I?
Run up the river project and storage.
This is a reservoir project. Reservoir project.
Reservoir. Yes. Reservoir. Not pump storage.
No, sir. This is a pump storage. That is why I just want to correct you, sir. In this Kadana also, the same situation had happened. Sir, I will just tell you what we are doing. Kadana also there was no reservoir, so accordingly the GSECL, the owner, never built pump starting equipment. Now they are basically with increase of requirement of PSP. Now Ministry of Power has asked BHL to run this Kadana also in pumping mode and Sadar Sarovar also in pumping mode in the same machine without changing anything by just adding some SFC basically pump.
Now it can be made another.
No, the same one. The same one will be run. The same one will be run without changing anything. The machines are pump storage, reversible pump turbines.
Downstream reservoir has not been constructed.
That's what they never wanted to run it in pumping mode. Now they are now government of MP, Maharashtra, and Gujarat have agreed to. There was an issue of raising the dam level, sir. That's why that lower reservoir never.
As and when they run it in a pumping mode, we can say today they are reservoir projects. The storage.
Fair enough. Fair enough. But that the machine is reversible pump turbine.
I'll explain. Sir, in Terry, there is a Terry dam, it's a reservoir. Now, the lower reservoir has been formed with Koteshwar Dam, which is 100-meter high dam. So that reservoir is the lower reservoir. For the pump turbine, it's a reversible. You can, but there is no reservoir, lower reservoir in Sardar Sarovar.
But the machines are there, sir. The machines are there. If the reservoir is coming, actually the reservoir is already coming, and it can be run.
It's a futuristic project.
We can make many PSP. I'm saying there is no problem, but as they are a storage project, not pump storage.
ना बोलो ऑडिट ऑब्जेक्शन हो जाएगा कि इन्होंने
No, what the nameplate says, sir, 6 into 200 reversible pump turbine.
हाँ वो लिखा हुआ है वो टर्बाइन है
वो है ही reversible.
लेकिन as of now it is functioning as reservoir conventional project.
Correct, because the owner has not chosen to run it in the pumping mode. Otherwise, machine में कोई दिक्कत थोड़ी ना.
हाँ ये बात भी अपनी जगह सही है.
Same. Sir, हाँ, कीमत तो लगी है सर, पीएसपी की।
When we were working on
हाँ,
Purulia
sir,
project,
everything was built as pump storage.
Purulia project, people said there's no such project anywhere.
कडाना भी सर पंप स्टोरेज ही है वो।
नहीं, सप्लाई ऑर्डर रिवर्सिबल टरबाइन का था या जनरेटिंग का था?
रिवर्सिबल पंप टरबाइन सर, तुम्हें इतना क्यों बोलूं? रिवर्सिबल पंप टरबाइन मैं कह तो रहा हूँ कि आज अगर रिजर्वायर पे एग्रीमेंट हो जाता है तीनों गवर्नमेंट का, एमपी, गुजरात और मध्य प्रदेश का, तो आज वो मशीन उल्टी तरफ से चल सकती है। और आज वो लोग चलाना चाह रहे हैं, वो बीएचएल को अप्रोच किए हुए हैं, उसमें हमें कुछ टरबाइन को बदलना नहीं पड़ेगा। जो नॉर्मल रिजर्वायर प्रोजेक्ट है सर, नॉर्मल जनरेशन प्रोजेक्ट, उसमें अगर आप नीचे रिजर्वायर बना के उल्टा चलाना चाहेंगे तो कभी नहीं चलेगा, उसकी 40% एफिशिएंसी भी नहीं आएगी, because reversible pump turbine is designed differently than normal conventional pump turbine.
From supplier point of view, it is a from your point of view, you have supplied a reversible turbine.
Capability तो उसी से आती है ना सर, आप वो it is installed there, आप चलाइए।
Actual project owner has to operate it.
Yes, that is what.
You are not the person who operates.
That is what I am saying, sir. The project owner never operated it in the. He bought it, but he never operated it. Shri Salam also and Nagarjuna Sagar.
Who did Purulia?
Purulia was done by Russians.
Japanese.
Is a PSP. Yeah, Japanese.
Sir, if I am to add, sir.
But sir, then, sir, can I just clarify, when CA says today that we have in the country 7 gigawatt of PSPs established, it includes all of this.
Okay.
You can verify from anywhere. It includes all of this. These are reversible pump turbines actually, never run in pumping mode. Yes, sir. Yes, sir. 100%. अरे सर, हम तो कह, आप घनश्याम प्रसाद जी से पूछे है, वो अलग बात सर, वो ओनर ने नहीं चलाया, मतलब हमारी गलती नहीं। अगर ओनर, अगर आपके मोबाइल में कोई फैसिलिटी आप नहीं यूज करें तो yes.
And then regenerating electricity. Why? I thought that this is an obvious thing, conclusion. Why are you raising objections?
No, sir, but Ghadgar and Kadampai is running.
It is not the capability of a particular machine that we are talking. We are talking of the project. They are not.
Fine, that is fine.
That's it. The question is that you have to raise the level of water through pumping, and then use that raised level of water to again generate power. In none of these we are doing that.
No, we are doing in Kadampai, sir. We are doing in Ghadgar. And those two not doing.
If they did not need a discussion, we are discussing that.
No problem. We can move it.
Okay.
नहीं, नागेश्वर but run for in pumping mode for 5-6 hours.
Concept अलग है ना वो। तू तो हर एक हाइड्रो प्रोजेक्ट को पीएसपी बोल दोगे तो कोई प्रॉब्लम ही नहीं।
नहीं सर, नहीं होगा ना।
नहीं, sir, unless Francis runner.
Tehri case, Tehri में तो pump and storage was 20.
Yes.
1,400, another 1,000.
Yes, sir. Yes. Because there was a lower reservoir available. They
your normal generation.
No, please. Sorry for the interruption. Please go ahead.
सर, आप ओनर से पूछ लीजिए, हम तो मैन्युफैक्चरर।
अभी eligibility of PHA we are not examining.
Rajan sir, the cost difference for Tehri was 1.32 times the pump storage plant as compared to the synchronous machine of the state. No, sir, I was in VHR for 20 years. This Kadampai, Kadana, and Shri Salam and Ghadgar I have not done, but Kadana. I have done that.
Next, sir. So these are also, as per President IEF, not qualifying, because these are also reversible pump turbines, presently running in pumping mode. But customer is not using it for generation because he has not built an upper reservoir there. ये लिफ्ट इरिगेशन है, ये अलग से है, सर 9.24 हमारी स्लाइड में आएगा ये। पर वो सीए की अगर आप साइट देखेंगे ना और रनिंग प्रोजेक्ट्स ऑफ पीएसपीस तो उसमें आपको ये दिखेगा. नेक्स्ट सर, द एम्फेसिस has been lost. हम ये कहना चाह रहे थे कि हमने कैपेबिलिटी हमारी थी, हमने उसको और होन किया है और डेवलप कर रखा है. वी आर रेडी फॉर द न्यू वेव ऑफ पीएसपीस which are coming. As I said, we have a center of excellence there in Bhopal. We have developed from scratch many probably all hydro turbines in the last 30 years, and number of PSP developments have been also made. Essentially, we have done model testing and kept ready for use as and when the market is required.
अभी ऑर्डर बुक की पोजीशन क्या है पीएचएल? What is the position of order book?
सर, हमारे अभी presently हमारे पास orders in hand is 4.5 gigawatt, 6.2 gigawatt.
PSP?
नहीं, PSP नहीं सर. PSP तो अभी नहीं है सर. PSP आज की तारीख.
No PSP.
Basically, there is a question on PQ requirement with BHL at moment, sir. It has been discussed at ministry level also. Pre-qualification requirement, BHL is not meeting the criteria as per present scenario. And I would like to say that BHL to go for high steady because PSPs are coming up with the standard machine most probably 250 megawatt or 300 megawatt. So BHL should start definitely manufacturing, do this all steady and all. And go for manufacturing without us seeing for order, first order. Otherwise, BHL will not meet the requirement of what we are going to bid now, all developers.
Chinese model.
Yes, sir.
Sir, ये forum को support करना चाहिए ना. I'm sorry, I'm speaking to Manoj from BHL. तो आपको सारा उन्होंने बता दिया, वहाँ दिखा दिया. We can, the machine can operate in the reversible way. Right. It can operate. Sir, but if we don't get the support from this forum, then साफ सही कह रहे थे. It is ultimately leading to the manufacturing capability. अगर आप कहते हैं PQR से नहीं होगा, then we are in trouble.
Basically, sir, this is what I would like to say. No, sorry. But sir, what I mean to say, basically, we have been supporting all the time. But basically, the need BHL instead of seeing for the order.
39 years in the company.
सर, अगला मैं बता देता हूँ. सर, गवर्नमेंट सेक्टर में मनोजा सर खाली 60 गीगावाट है. बाकी 200 में तो सारा का सारा प्राइवेट में है. Private is allowing BHL. They have trust in our capability.
Sir, I must add.
Tatas and Adanis we have already bid and अब तो और भी जगह कर रहे हैं. It is time that our fellow PSUs also see that capability.
साहब लोगों से आनी है, वर्मा साहब आनी है ना सपोर्ट तो वो.
Because I want to say be happy and enjoy life now. So.
नहीं सर, ऐसा नहीं रहा.
नहीं अब मेरा टाइम होगा 5 बजे, मतलब मैंने जाना है.
सर, इसमें मेरे आगे कुछ खाली पिक्चर्स थे मैन्युफैक्चरिंग फैसिलिटी की, तो प्रॉब्ली नॉट रिक्वायर्ड. बट हम सिर्फ यहाँ ये बोलने आए थे कि सर, कन्वेंशनल हाइड्रो में अभी हम इन टर्म्स ऑफ एफिशिएंसी, इन टर्म्स ऑफ टेक्नोलॉजी, वी आर बीटिंग आवर वर्ल्ड लीडर्स, है ना. अभी अगर डिबांग है जो कि इस कंट्री का हाईएस्ट हाइड्रो पावर कैपेसिटी है, उसमें टेक्निकल लोडिंग में बहुत वॉइस एंड हैंड्रेड्स वर लोडेड बाय 100 crore, नॉट बीएचएल. तो अभी हम वो टेक्नोलॉजी डेफिसिट नहीं है, लेकिन चूंकि वो रेफरेंसेस बहुत पुराने थे और जैसे सर कह रहे हैं कि वो कभी पंपिंग मोड में नहीं चला है, क्या अगर है भी तो अगर पिछले 20 साल में नहीं चला है तो इट इज नॉट बीइंग कंसीडर्ड फॉर पीक्यू. सो द पिच वी आर मेकिंग टू मिनिस्ट्री आल्सो कि all machines we were a partner of BP.
Sir, इसमें I would like to specify, sir.
Can you tell us that what measures you have taken for erosion resistant materials?
Sir, if you search my name, you will get at least 1 dozen international papers for erosion resistance.
Not paper, actually.
We have an HVF plant in Bhopal. We do it in 2 ways, sir. First is you can have a profile which is inherently less resistant to erosion. How that is done is my trade secret. I will not dwell, but you can have that. Basically, because in runner the sand particles are continuously being
manufactured. Have you taken any special precautions for that silt erosion?
Yes, sir. That is what the second thing which is the industry standard, is HVF coating. Basically, there is a hard coating on the runner surface. we have a full-fledged plant for HVF coating, which also I guess no other manufacturer in the country has. Auto manufacturer.
But sir, the point अभी जो था बीच में, जिस क्वांटिटीज में हम लोग जाना चाह रहे हैं, उसका यू डन स्टडी कि अगर हम उसको स्टैंडर्डाइज कर दें अपनी मशीन को, if you want in those numbers, जैसे वो कह रहे थे कि 250 की या 125 150 की कोई ऑप्टिमाइज साइज कर दें, जो कि कंट्री का रीजनेबल अब कुछ असेसमेंट हो गया है, क्योंकि अदरवाइज आप हर एक कहेगा मुझे 135 चाहिए, 175 चाहिए, 220 चाहिए, तो दैट विल टेक टाइम.
Exactly.
बल्क ऑर्डरिंग
should be in fixed
स्टैंडर्डाइज, उसका कोई ऑप्टिमाइज साइज जो आप देख कर.
सर अब इसमें मैं दो बातें बोल सकता हूँ. सर जब आप बोल रहे हैं ऑप्टिमाइज साइज ही हो रहा है 200 मेगावाट, 250 मेगावाट एंड 300 तो अभी देखा नहीं है, पर 300 भी आ सकता है. जैसे चेयरपर्सन ने अभी कहा कि वो 300 मेगावाट के बीइंग एनविसाइज्ड, 200, 250, 150 यही स्टैंडर्ड साइजेस है. बट इसमें स्टैंडर्डाइजेशन कितना है ये मैं बता देता हूँ, बिकॉज आई एम अ डिजाइनर, आई कैन टेल यू जस्ट वन लाइन. टर्बाइन विल नेवर बी सेम, बिकॉज हेड अलग अलग होता है. दो जगह रिजर्वायर एक ही हेड के नहीं बन सकते सर, तो उसके अकॉर्डिंगली जनरेटर का स्पीड भी अलग होगा. ठीक है. व्हाट विल बी स्टैंडर्डाइज्ड इज रेस्ट ऑफ द थिंग्स, ट्रांसफॉर्मर, जितने बीओपीज हैं वो सब स्टैंडर्डाइज हो जाएंगे, तो उससे साइकिल फास्ट हो जाएगा. और कर रहे हैं, चाइना भी यही कर रहा है. 200 250 फिक्स किया हुआ है उसने मेगावाट. जब आप ऑफ रिवर बना रहे हैं ना सर, सो यू आर नॉट बाउंड विद द रिवर फ्लो एटसेट्रा एटसेट्रा. यू कैन डिसाइड ऑन योर ओन इतना कितना रिजर्वायर साइज चाहिए, इतना मेगावाट है मेरा, इतने यूनिट्स चाहिए, जिसको मैं 4 घंटे या 6 घंटे चलाना चाहता हूँ, जैसे आप कह रहे हैं. तो देन you have the flexibility of deciding megawatt only. But the head, जैसे पिन्नापुरम का हेड इज लाइक 120, तेहरी का हेड वाज 270, और देयर विल बी अदर हेड्स.
We are making modular projects, sir. We have made Pinnapuram. MP, which we are making, is the same machine, same
yes,
head, same everything, sir. We have total 11 projects which are to come up till 2032. We'll be using only 3 type of machines. Now this 3,660 megawatt machine, which Chairman Sahab said, that is same machine as in another project of 1830 megawatt project, and same machine for another project of 2000 something.
That is what we are doing.
So if we can off stream, it is possible to do modular projects, sir, and we should try to do. We are doing it for almost 2 to 3 projects of same machine we are doing.
Sir, all developers are doing that.
Yes,
actually all developers.
वो you see, अगर आपने इस वॉल्यूम में उस टाइप ऑफ इलेक्ट्रिसिटी को बढ़ाना है, तो आई थिंक यू विल हैव टू
ये तो करना ही पड़ेगा.
यस, एंड कॉम्प्रोमाइज. यस, अब यही नहीं कि मेरा 15 मेगावाट और हो सकता है, 20 हो सकता है, भूलो उसको.
नहीं सर, और हम बिगेस्ट मशीन 320 megawatt का we have already ordered on GE, sir, which is under manufacturing for one of our projects. Yes, Saundati project, that is 320 megawatt GE machine, which is already under production. नहीं, उन्होंने बात किया.
BHEL being not qualified by PSUs for PSPs.
No, sir, no. It is not that. Basically, this discussion had been happening at ministry level. Not only PSU,
you
rather
said that
we had been blindly supporting this. But
No,
what
no,
I
you said
suggested
that
on
they are
this
not
forum,
qualified technically.
yes, sir,
for
because no
PSPs.
machine has been manufactured up till now by BHEL directly. Because we are now looking ahead for the indigenous technology. One of the point on this. And what I just suggested, I with folded and excuse to sir, I just suggested BHEL should go immediately for model testing and all for 6 type of machine.
Sir, last slide दिखा दीजिए. Last slide दिखा दीजिए.
That is more important at this need.
एक slide दिखा दीजिए.
So if they go, if they succeed in
ये
model
सब हमारे
testing, then
pictures
they'll
हैं
be
जो वहाँ
qualified.
facility है. ना last slide, एकदम last.
सर उसमें,
हाँ पीछे, इसके पीछे.
सर उसमें मैं क्या करूँगा सर?
ये पिक्चर
जैसे हमारा कोई PQ रिक्वायरमेंट नहीं था सर.
नहीं सर, आप जो पूछ रहे हैं मॉडल टेस्टिंग, आप एक बार भोपाल आ जाइए, आपको इस तरह के 8 या 10 मॉडल दिखा देंगे. Not one.
सर BHEL के साथ हम लोग being private party, we tried hard with BHEL for two of our projects. At that time, they were just reviving the things. Now they are ready to do that part. But only part I think where BHEL will have to compete broadly with the vendors will be the timeline, sir. Technical capability wise, no doubt, sir. Their facilities, everything is best enough as compared to any bidder that way. But timeline is an area I think where they will have to do a lot of things to match those.
Sir, we will work on that. Now that we are bidding with Adani and Tatas, obviously timelines are being taken care of to their satisfaction. मतलब अभी हमने ऑर्डर नहीं मिला है, but we are bidding.
पीएसपी फ्रंट पे बीएचईएल के पास कितने साल का ऑर्डर बुक है या अभी कितने ऑर्डर आप ले सकते हैं, ऐसे कुछ?
सर अभी मैंने दिखाया, हम इस वक्त अगर
इस वक्त कोई ऑर्डर है?
देयर इज एमओपी में देयर हैज बीन अ बिग डिस्कशन. इस वक्त देश में सिर्फ 2 मैन्युफैक्चरर बचे हैं. जी इज ऑन इट्स वे आउट, सो अदर देन बीएचईएल, और उनकी इंस्टॉल्ड कैपेसिटी इज नोन टू मिनिस्ट्री ऑफ पावर. उन सब में सबसे बड़ी मैन्युफैक्चरिंग कैपेसिटी बीएचईएल की है. तो 200 गीगावाट अगर आप अगले 10 साल, 15 साल, 20 साल में भी करना चाहते हैं तो पीपल आर कैलकुलेटिंग बेसिकली. आज सुबह भी मेंबर हाइड्रो चेयर सी हमसे बात कर रहे थे रिगार्डिंग व्हाट कैन बी really achievable target with respect to manufacturers' capability available in the country.
Now, sir, देखिए, we are hugging China, and we will have to. They will, then they will think of coming here. So you better tighten your socks.
Sure.
Belt.
That's a point well made.
BHEL is need of the hour, sir, because we can.
What I learned was that BHEL has a capacity of about 2,500 megawatts per annum.
In our one block, sir, that is hydro block, we have a total annual capacity of 7 gigawatt, which is same. Sir. The PSP and hydro will not require different machinery. It is absolutely same. Absolutely same.
We should not face the same situation what we faced in thermal earlier. Some of your capacity goes for R&M of the existing machines, and the net capacity available is too less to meet the country's requirement. And the point Mr. Verma raised about your qualification requirements are not meeting. You must do something regarding that.
We are doing that.
What I see is a great opportunity for BHEL in hydro, and you have to increase and augment your capacity, go for modular projects, and also for standardization, taking the power developer into confidence. Maybe you can have a lot of discussion with them.
We are taking them to our facility.
Yeah, because otherwise, if your capacity, what I understood was written here, be 2,500 megawatt. Now you say this is not 25, and this is how much?
7 gigawatts.
7 gigawatt per.
That was 2.5 gigawatt per annum. This is, sir, that is considering only the hydro block of Bhopal, BHEL Bhopal. The annual declared capacity in Ministry of Power is 7 gigawatt.
7 gigawatts.
7 is not enough.
So,
but the other manufacturers are having even half of that.
No, but just see. What
we will increase.
Chairman said,
we will increase that.
Listen, Chairman CA said that there is a potential of 214 gigawatts in PSPs alone. Now, if you have 7 gigawatts, so this will take 30 years to supply all this equipment. If you are the only,
they will not be the only one.
We will not.
Maybe there is one more, but this has to be achieved in 5 years. You know, if we have to.
Now let's close it. A few points, and then we ask our friend to propose vote of thanks. I think this has been a very absorbing session, starting from the chief guest himself, extensively explaining what is going to happen and what is happening. And that was very promising, 214 gigawatt of potential. With 214 gigawatt of potential, I think solar, wind, hydro and pump storage. Solar, wind, hydro and pump storage.
That package is going to completely transform our independence on energy transition management in a great way in the next 10 to 15, 20 years. So, and this is doable. Imagine in the last 75 years, we have reached a little more than 50,000 megawatt on hydro and 214,000 or 218,000, 100,000 megawatt of pump storage in the hydro group is really a remarkable assessment. And that assessment seems to be real because some of the things as potential as they have been studied on investigation, they are found to be perfectly in order as estimated. So that's going on well. A number of public and private sector companies have, with great enthusiasm, joined the thing. At one stage, about 3-4 months back, which I mentioned in the introductory remarks, when I came to know in one such discussion that the state governments are using as a license through MOU. And then I reminded the Central City Authority chairman, and he quickly, therefore, worked on this. And now the position is that hydropower within certain investment and pump storage, irrespective of investment in a big way, if it is closed loop, it is de-licensed. It's not licensed. You need to, if you feel, you need to go to Central City Authority and CWC for consultation, so long as it is a closed loop pump storage project. So that is a good development insofar as the administrative process, regulatory process, and the process of getting so-called techno-economic clearance is concerned. The issue that has come up today in a big way, that if this is the vast potential, and if this is the solution to the massive expansion of solar project as a backup, are we prepared on manufacturing? Solar, we went in a big way. We are not prepared. A lot of dependence on import of solar modules and other things. And quickly in solar, it was made possible that a number of private sector have come up. So far as BHL is concerned, in one such meeting about 3-4 years back, I did say that solar manufacturing also in a significant way belonged to BHL. But BHL is in margin on that. So therefore, let it not repeat when it comes to the huge opportunities that exist for pump storage. 2.5 gigawatt is insufficient, as the point has been made, with reference to the expansion that we are anticipating. And initial studies on almost 10,000 megawatt on pump storage indicate that you don't have that much of a hassle as we normally have had and continue to have in typical hydro projects. These are, it's not that it is oversimplified, but in a great way, it is quite different and more simplified as compared to the typical hydro project, and that it is possible, particularly the closed loop hydro pump storage projects. So I think this is a great opportunity for all of us. Chairman CA also made a point that some of the things that are being considered, they should be considered seriously. India Energy Forum will also work for this, that pump storage should get at least that dispensation in terms of any concession or benefits in tax matter or any incentivization as we are giving to other renewable projects, because all other renewable projects, and in the lead is the solar project, minus pump storage solar project has issues and challenges. And therefore, if anything, this should be looked upon with even greater understanding and greater degree of consideration. I made the point in the beginning that this type of appreciation and this type of importance that is being recognized at central level is not at this point of time being recognized at the administrative level or the political level, insofar as the state governments are concerned. So therefore, those who are developers and those who are working for it, they have the difficulty, and there would be a need to pursue with the help of central government. And I mentioned that they should try to have a chief minister's conference or at least power minister's conference to sort out these issues in which local, state level forest people, environment people should be associated with the process. And they must recognize the great importance and significance of this particular technology that has come up so handy for us. I think with these words and with the advice to the BHL and also Tehri Corporation that BHL is our important manufacturing setup. Definitely, unless we give them chance, and we did it in certain cases. You have a performance guarantee with BHL,
Yes, sir.
and don't cut them out at the eligibility level because this is not such a complicated thing that it can be done. In fact, in my introductory remarks, I said that some of the other engineering manufacturers will also be allowed to do because if we have to meet with this type of a requirement, perhaps only a couple of manufacturers may not be adequate. We may need to have more manufacturers. And the commercial answer is that if they are because pump storage opportunities were not there in the past. So therefore, to have the eligibility that you should have had this, it will be impossible to have. So unless the developers understand this, you can't match the two requirements. So you should definitely consider them with commercial guarantees, performance guarantee that they are with you for 2, 3, 4 years, and that is how it goes. And that process will enable both the developers to meet the requirement and the manufacturers to keep up to it so that our huge dependence largely or vastly on import is reduced. I think with these words, I thank you very much. This has been a very absorbing session with a lot of wise comments. We have very eminent personalities in this, who is who of power sector in last few decades, and it has been very enriching. Thank you very much. बाकी चीज चाय में
So thank you very much, sir. Thank you. Sir, thank you. Thank you very much.
Vote of thanks.
Thank you very much. It's my proud privilege and honor to present the vote of thanks with the permission of our President IEF and Chairman Power Group, Dr. Bajaj. So firstly, I would like to specially thank Shri Ghanshyam Das ji, who Chairperson of CA, who was our chief guest, but he has online, he has graced the occasion and delivered the special address. We are indeed grateful to him and what for the knowledge he has shared on the theme of the pump storage and also the questions which was raised also on the transmission. Once again, we thank the Chairman CA in his absence. I also express my gratitude to our President, Shri R.V. Shahi ji, and former Secretary Power, Government of India, for delivering the presidential address and expressing his most insightful views on the theme. And also, in his concluding remarks, he has suggested to BHEL to come up with the capabilities of BHEL is there, but the volume of the work which is there for the establishment of this PSP, so they have to think it over and this. So I also thank Dr. H.L. Bajaj, the chairman of the Power Group and former chairperson of CA, for his welcome address and also the interaction which he had during the session. I would also like to thank Shri Rajiv Vishnoy ji, CMD, in his absence and for nominating Shri Neeraj Verma, Executive Director, THDC, along with this team of 3 senior officers who have given the detailed presentation and sharing the experience of the execution of the commissioning of Tehri PSP. We express our sincere thanks to the whole team of THDC for sharing the knowledge of execution and commissioning of the variable speed machine. I would also like to thank Shri Parveen Nandaji, Executive Vice President, Greenco Energy, for having shared his experience and knowledge of the execution and commissioning of the off-river 1600 megawatt Pinnapuram pump storage project. We have also appreciate his elaboration on the basket of PSPs under various stages of development by the Greenco Energy in the private sector. His presentation has been very excellent and we congratulate him for going ahead with the PSP development in his organization. I would also like to thank Shri V.S. Raoji, General Manager, BHEL, for giving a elaborate insight into the BHEL's capabilities, ensuring its readiness to match the requirements of manufacture and supplies for reversible hydrogenating equipment to meet the requirement for the PSPs, subject to the remarks what our President Shri Shahi ji has given, and also Dr. Bajaj has given certain advice in the matter for enhancing its capacities in the manufacturing. I would also like to thank all the members of the IEF, speakers, guest invitees for your engagement and enthusiasm towards this seminar. Finally, I would like to acknowledge and thank Shri Rawat ji, Manager Administration, India Energy Forum, who has been working endlessly behind the scenes to make it a success. Thank you all once again for being a part of this seminar and requesting all of you to join the high tea served on the same
But
floor.
before that, I would like to acknowledge and thank our Anil Razdan, great friend. He has made it because despite I know so many things he has to do, he is very busy, but he's quite often attends and very important suggestions he makes with his vast experience. He has been a very valued colleague and he continues to be our great friend and great friend of the, he is a part of our process. So you missed thanking him.
Yeah. No,
right after me, you should have thanked. That's okay. That's okay. Thank you very much.
Thank you very much.
Thank you.
My duty.
Sir, at the end,
I don't thank
Shahi Sahab.
Mr. Mahajan, who is our Secretary General, and he has been very helpful in guiding and making all the arrangements. And I'm also very thankful to Mr. Satish Sharma, who has been doing the designing of the.
And you are not thankful to me.
Sir,
we are part of the
The tea will be served in the fire on the ground floor as soon as you come out of the
No,
lift
no, no.
on
It's,
the
on,
right
it's on
side.
the second floor, same floor.
Yeah, there.
Yeah, sir. It's on the same floor.
Very good.
So I already said, sir. One thing has left out. We would like to honor the speakers, so you have to give some presentation. So I will request you to give the presentation to Mr. Neeraj Verma. Lead Director. Mr. Parveen. Nandaji. Shri V.S. Rao ji.
आप वहीं रहिए बजाज साहब भी आएंगे पिक्चर में
मेरे को खड़ा तो होने दीजिए
हाँ या ओके